Okay, so good evening, guys. Hopefully, you are doing great, I guess. So, today we are going to continue with the next advanced stuff, as I mentioned last time. So, we started with containers. We saw how containers can be created, how containers can be, maybe containers can be started, containers can be restarted, containers can be, deleted or removed, and how images can be dealt with, and so on and so forth. We also have seen So we also have seen the images and how we can create those images by using Docker file. So this is what we are kind of, yes, we have kind of seen that last time. Now today we want to continue further and we want to see some advanced images. We want to see advanced containers. We want to see the containers networking, volumes, and whatnot. There are many different things we are going to see today. Okay. But before that, let me just go back and let me show you the,
Sir,
yeah, who's that?
sir, sorry to interrupt you, sir. Pradnya ma'am, sir.
Yes, ma'am.
Sir, sorry to interrupt you, but that code sharing code I'm not getting. Can you please post me on my WhatsApp or personal chat?
Yeah, no problem. I share it with Rahul, sir. I think it's better I can share with you as well. Just give me a minute. I'll share that with you. Okay, I did. I think Pradhan, you got it
Just
on
I'm
your chat.
checking, sir. Yes, sir. Yes, sir.
Okay,
Received, sir.
received, right. Okay.
Uh, PG courses, please wait. Online courses, please wait for 2 minutes. I'm posting. Sir,
Anyways,
please continue, sir.
yeah, it will take a couple of more minutes to start coding, so nothing to be
Yes, sir.
worried about. Okay. Okay. So before we start with the actual session,
Yes, sir. Yes, sir.
yeah, before we start with the actual session, I want to just show you a couple of things so that by the time in background you can start downloading the stuff. I mean, we need that later today, or maybe we'll need that tomorrow. So be ready with it. I'll show you the steps. You go ahead and you do it. Okay. First thing, you download the virtual box. So go ahead onto the virtualbox.org. There you will find the download list. So download button, go to that download button, and depending on which operating system you are, you can download the required version for your machine. So I'm going to put that link right here on your chat, so you can go there and you can download this. On top of it, download the other one as well. That's called as vagrantup.com. That's where you will find the latest version. Go to download the Vagrant Up, go to download 2.2.2, whatever it is. Depending again on your operating system, choose whichever version is suitable for your operating system, and just download and install this. First install VirtualBox, then install Vagrant. That's it. These are the two things that you have to install on your machine so that you can do the cluster practical along with me. So later on we have to create a cluster. Cluster is going to be connecting multiple machines together, and because you are having only one physical machine, we have to have at least two or three virtual machines in order to connect them together and build one cluster of virtual machines. So that is the reason why we want to go for Vagrant. Don't ask the question what is Vagrant and other thing. It's not needed right now. Just install it. Whatever I'm just telling you, just do it. Trust me, it will work out. Okay. So this is Vagrant. Just download VirtualBox and just download that Vagrant. Now, once you download this, I want you to download. I want to download the another Vagrant image by saying something called as Vagrant box add bento slash Ubuntu. Just a sec. I don't want to make any mistake. Just a sec. It's better I can copy and paste. So this is bento 18.04. Add bento Ubuntu 18.04. So this is what I want you to do. So again, this is the third step. First step is download VirtualBox. Second step is download Vagrant. Once both of them are installed properly, open your command prompt, open your terminal, open your console, depending on your operating system, and go on anywhere on your command prompt and give this command: Vagrant box add bento slash Ubuntu 18.04. That's it. So this is the third step. Now the fourth step, you can go back and I'm going to share that file with you right now. So where is it? Where is it? Here it is. So data, practice, Docker, and Docker cluster.zip. So I'm sharing this file on your chat. So go ahead and probably you can download this. Once you download, extract it. This is a zip file. Extract it somewhere, possibly on your D drive if you're on Windows, for example, or maybe somewhere you're having kind of maybe at least couple of GBs space. So go ahead and extract it somewhere. After you extract it, you will find a folder cluster. Go back to your command prompt and go to that directory. So I'm in practice docker cluster. So go to that directory. Once you extract it, you will find a file, vagrant file, and init.sh. Use a command vagrant up. That's it. Don't do anything other than that. Just say vagrant up. So go to that directory and say vagrant up. Okay. So otherwise it won't work. So let me put this command as well. So there are the 4 steps you have to do. Let me repeat myself. First, download VirtualBox. Second, download Vagrant. Once these two downloads and once these two get installed properly, go back to your command prompt and use this command, Vagrant. I'm just gonna go back here. I'll say Vagrant box add bento. I already have pasted that there, so you can copy from there. Bento slash Ubuntu dash 18 point, I'm sorry, 18 point, what the hell, 18.04. That's it. This is the one you have to use. And then you extract that zip file which I gave you on your chat, extract it, go to the directory, and the fourth and the last command, just say vagrant up. That's it. Once you do that, you'll be having two machines, two virtual machines on your machine. So if I go back to my virtual box, for example, I can show you that right now. So you can also confirm whether things are really working for you. I'm having these two, I mean, this is master node, node 1, node 2. That's okay. So these are for Kubernetes. We are going to need that next Saturday, Sunday. And this is for today. I mean, I'm running 3, but on your machine, you will see only 2 of them. So probably you can just change that, and probably you can, maybe you can give it a try, and then you can do these things again. Okay. Tushar, I mentioned that earlier as well. I mean, I'll show you one more thing, one more time. So probably see here. So one, I'll mention it here. Download VirtualBox. You must have received them on your WhatsApp group as well. Those Docker Kubernetes group members, you can see them there as well. Then download Vagrant. Now you know where you can find them. After installation, open terminal and execute the command. Which command? The command is vagrant box add bento. There is no space in between. Ubuntu dash 18.04. Sorry, 18.04. That's it. Then maybe download and extract the file. Extract the cluster.zip file, the one which I shared on your chat, and we'll share that on WhatsApp as well one more time. And then this is the last one. Go to the directory on command prompt or console or terminal and follow this command, vagrant up. That's it. Okay. So that is what you are supposed to do. If you face any problem, go on internet, go on Google and fix that. This is nothing related to the Docker. This is nothing related to the Kubernetes. So we don't want to waste more time onto it. Let's go on to our subject. This is needed for testing purpose. I mean, actually speaking, you should use the physical machine, 2 or 3 physical machines in order to create the cluster. But not everyone is having multiple machines. I can do it right now, but that doesn't mean like you will have the physical machines with you. So it's better you can go with the simple option, something like a virtual machine like this. So that's the reason why we are using it. So it's just an adjustment. So if you have any problem, go onto Google and give it a try. You cannot use the Google Playground for the, I mean, Docker Playground for creating a cluster. That's a problem, Harshit. It is having only a few minutes session. That's one problem. And second, cluster is not problem. Cluster is the problem. You can use only for the simple commands. I mean, yeah, that's okay. You can play with the Docker and you can use it, but it has a limitation. It can give you only one host. You cannot build a cluster there. For a cluster, you have to have multiple machines. That's a problem. That's the reason why am I saying you this. And not for this week alone. Next week, when we want to go for Kubernetes, There also, I'm going to share one more file with you where you will have 2 or 3 machines, depending on your capacity, depending on your configuration. You can have those machines there. Now, I'm going to show you like two, let's say worker machines and one master machine. Similar, we'll do it here for Docker as well. Okay. We'll talk about all of these things later in Kubernetes course, but today, at least get these things done, and probably that will solve your problem. Okay. Okay, so I already have, installed that. I already am running it there. So probably everything is okay. Hopefully, it will take some time for you. So probably you can do it later. Oh, have they added the new functionality now? We can create the multiple clusters. Okay, I am not aware about that then, because last time when I used it, it wasn't having a kind of a cluster support. If they have added them, then it's okay. Then it's not a big deal. Okay, but I think it's better you can do on your own machine. That will give you one, faster speed, and second, first-hand experience instead of just using someone else's machine. It's better to start something from scratch. So you will get couple of more things when or couple of more things you will learn while building your own cluster, by building your new virtual machine. And on top of it, what I like to do is like learn as much as you can. This tool which I'm sharing with you, Vagrant, it's one of the best tools when you are going for virtualization. Believe me or not, when you are going for DevOps, this is the starting point. People generally don't appreciate it unless they use it. So start using it and you will see a benefit of it. Anyways, so maybe you can get it today, get it tomorrow, or at least get it maybe till next week. Today and tomorrow, if you want to do along practical along with me, do it. Okay. Okay, so now enough about that. Let's continue our own business now. So probably last time we started working with the images, and if I'm not mistaken, we have started talking about few things there, like what is an image, how to create an image, how to start with a Docker file and stuff like that. Okay. Yes, Kavish, if you want, you can install. If it has to, you have to restart it. Can't help. You know. So this is what we are going to start with again. That's a Docker images. But today we will start with a little bit advanced version of it. Last time we saw small, or you can say simple demos. Now today we are going to start with a little bit advanced demo. Now we'll quickly revise what we have seen in the Docker file, and then we'll look at some more advanced use cases. The Docker file contains the series of instructions paired with arguments. That's what we have said last time. Probably you can recall this. We said that this is the one which is going to have different instructions, and every instruction in a Docker file will create a new layer in your image. This is something we have talked about last time. So hopefully you can recall that. Each instruction should be in uppercase and be followed by an argument, naturally, because every instruction is nothing but a command plus argument. Instructions are processed from top to bottom because it's a scripting file, kind of. Each instruction adds a new layer to your image and then commits it in an images. So this is exactly what I mentioned earlier. Every command is going to create a new layer. Upon running, changes made by instructions may make it into the cluster. So whatever instructions you are giving inside Docker file will be added inside the container. So precisely, whenever you are using command inside your Docker file, let's imagine that this is nothing but my Docker file. So inside it, this is the instruction, this is the instruction, this is the instruction, this is an instruction. So probably when the image gets built, this is an image. So every instruction is going to create one layer inside your image. So this is going to be another image. This is going to be another, sorry, this is going to be another layer. This is going to be one more layer. And finally, this is going to be one more layer. So all of them are nothing but the layers. So every instruction is going to create a layer. And basically when we talk about, a container is nothing but image layers. On top of that, we create a writable layer. This is what we have discussed last time. So when we are talking about a Docker file, these are all possible options for you. Depending again on what you want to do, you can use a few of those instructions. Not every instruction is needed, and not every instruction is something that you have to use, but you are going to use most of them. And I guess I talked about almost all of them. I gave you a couple of demos last time, and we have seen how to create a simple image out of that Docker file. Okay, so I'm sorry, we talked about all of them. Now we talk about a couple of advanced demos. And before that, I think we'll just bring everyone in a context. So we'll see how we can create a small image out of a simple HTML file and see how we can run that inside either HTTPD, or maybe we can run that in Nginx. See how it can be done. I'm going to go back to the directory which you are able to see on your screen on your student portal, so everyone can see my code and everyone can copy paste the code if needed. So I'm going to go back to today, and inside the Docker, hopefully here it is. I'm going to create a new directory called as, let's say, image1. Yeah. So inside that image1, I'm going to start writing the code. So I need a file named Docker file. We mentioned that last time, something like this, Docker file. You start adding all of the instructions there. Now, before we start adding the instruction, let me just create a very simple index.html. It's quick revision of what we have done last time. So this is going to be my simple HTML file. Don't write anything, just copy and paste. It will make your life a little bit simpler, you know. So that's the page one, or that's an index, whatever. I'm going to say this is h1. This is a demo website, as simple as that. Now this is the demo website. Right inside this, we'll start creating a simple image by using different commands. The very first command, which is mandatory, is a from. From is nothing but it will allow you to select your base image. Now the one which I want to run is a website, and because it's a website, it's going to have HTML pages, and those HTML pages we want to put them inside one of the web servers. Which web server should I go for? I think maybe I have two options. Either I can go for Nginx or I can go for HTTPD. I think better option we go for Nginx. If it is an Nginx, again, I can go back to hub.docker.com. I'm going to search for Nginx and we'll see the path, and there we will copy and paste the image. So this is Nginx. This is the one that I want to use. And in this Nginx, probably we see that we have to use this particular path in order to copy our index.html file there. So this is Nginx image we will start with. Second, I'm going to copy that index.html there. Or maybe we can go for HTTPD if you really want to. All depends on you. I'm going to show you both of these options here. So it's better. This is the one. I'm going to search for HTTPD. That's the rather simpler one. So you can, if it is Nginx, you can use that path. If it is HTTPD, you can use this path, whichever. It all depends on you. Let's use this one. Doesn't matter. So maybe I can say copy this index.html from the current directory. You may say dot slash current directory to somewhere in slash usr slash local slash apache slash htdocs. If you really want to just use kind of a dot everywhere in the destination, you can also set the working directory. You can set the working directory there, and then you don't have to use that path everywhere. You just say dot, and this will refer the working directory. So whenever I see dot on the right hand side, which is a destination, it will always refer to that fact slash slash usr slash local slash apache 2 slash htdocs. That's it. I mean, we are almost done. We have to expose a port number, let's say 80, because my Apache is going to run on port number 80. It will listen for HTTP protocol on, let's say, port 80. That's the reason we have to expose that port number. And finally, we have to run Apache in foreground mode. So I'm going to say cmd, cmd Apache cdl minus d foreground. That's it. So that's the only thing which we need in order to create our image. That's it. So now I can go back to my command prompt and I can build my image. So image ls, docker image, docker image ls. Seems like we are having a couple of images there. That's okay, but nowhere I can see our image. So I'm going to say docker image build minus t for tag. I'm going to say my image dot means it's where it is going to find the docker file. So maybe I can say this is the docker file. It's going to create that right now. And again, if I go back and say docker image ls, it shows me that my image now exists right there. 6 seconds ago, just now I built it. So the image is there. Now I want to create a container out of it. I'm going to say docker, container run minus I T D. Probably you all remember what is that minus ITD? Interactive, teletype, D for detached, right? Maybe I want to assign a name, my container, for example, from an image, my image. Because this is a website, because it is going to run Apache inside it on port number 80, I'm going to use a port mapping here, -p. Maybe on my machine I'm going to use port number 9090, which is going to map to port number 80 inside the container. That's it. When I say run, hopefully if I say docker container ls, it seems like it is running on port number 9090, meaning if I go back and say this is going to be localhost colon 9090, hopefully it shows me this is the website, this is the demo website. I mean, I am almost like 300%, so that's the reason why it is too big. This is the original version, this is a demo website. So what you see here is a very simple example about how to create a new image and how to create a container out of it. That's it, as simple as that. I hope everyone is able to recall whatever we have seen here, and this is nothing new. Okay, now when we are using this copy for copying the image or copying something from my machine to the destination machine like this, you can use one more alternative for that copy, and that is something called as add. So you see that there are two options here. One is called as the copy somewhere here, and the other one is equals to add. I mean, right now, if I just go back and replace this add here, still everything is going to work. Let me show you a simple demo of it. First, we'll have to stop the container. So I'm going to say docker container rm --force because it is running my container. Let us delete that container. Let us delete the image as well. Image rm my image. Let us delete that image as well. And I'm going to rebuild that image. See, this is where I have replaced a copy with add because both of them are going to do the similar job. I'm going to go back here and use the same command, docker image build -t my image dot means it's the directory where it is going to find the docker file. Okay, so yep, I can see that docker image ls. It seems like my image got just created 3 seconds ago, which means it's just created now. And then I'm going to create the command container out of it again, like last time. The container is going to be remain same. There's no change here. And if I go back to the browser and if I say refresh, everything is working as per expectation because there is no change. You see here, because we have replaced that copy with add, everything is going to work exactly like it was working earlier. So what I want to say here is you have got two options. You can use either add or copy because both of them are going to do exactly similar job. I mean, there is no as such difference that you can use copy and add, except there are two, majorly two. So what is the difference between copy and add? You see here, a copy is a later command, or you can say it's a newer command, while add is an older command. So Docker, maybe when they started using or when they started providing this feature to create the Docker images, they started giving this add command. And today, I mean, we are having two options with this. You can use the older command add, and you can also use the newer command, something like a copy. So that's the kind of, you can say, older command and newer command. So again, depending on your choice, you can go for using add or using copy. So isn't there any real difference between these two? Oh yeah, there is a real difference, actually speaking. So what's that real difference is? The real difference is you cannot copy files from URLs by using copy. In a sense, if you want to download a file and you want to put that right inside the container, you cannot use a copy there. Meaning, for example, let me go back here and say if I have a file, let's say there is a image file, there is an index file, maybe there is some file on the internet and I want to use that URL and I want to copy that URL directly onto the destination. This is where I can't use copy. So copy can be used only for copying the local resources or local files to the destination, not from the URL. So if you want to download something from URL, you have to use add. So it cannot copy something from URL, but add can copy the contents from URL. So you may say add http :/ blah 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 and the destination directory in your container. That is possible, but you cannot say copy there because copy cannot download the resources from internet, from a URL. So URLs, if you are using any to download the files at the time of building an image, it's not possible with the command copy. It has to be command add. So remember this. This is difference number one. The major difference with, major difference between this copy and add is another difference between copy and add is like it cannot be used to extract an archive file to the destination, while this can be used to extract the contents of an archive file to the destination there. What do you mean by that? This is very simple. I can show you a small demo of it. Check this out. I'm going to go back to the directory here just for an example. And probably I'm going to create, let's say I'm going to open that in my Finder somewhere here. This is my image one. And let us create, let's say, a couple of files there. Let's say this is going to be my file one, just for an example, file1.txt. This is a file one. Let me add one more file, file2.txt. This is file two. Let's add one more, say file3.txt, and say this is, I'm sorry, this is a file three. I'm sorry, file three. That's it. So we have got three files there. Now what I'm going to do here is I'm going to literally select all of them and create a zip file here. Let's say this is archive.zip. I'm going to rename this to file or maybe files.zip, something like this. So probably what we are trying to say here is like, I want to copy the contents of this files.zip to somewhere in that destination directory. So how do we do this? Can I say copy here? No, you can't. You have to use add there. I mean, here I can say copy because we are copying this local file, that index.html, to the destination. So there I can use copy, but here I have no option but to go for add. Let's see if I say add, see what's the difference here. I'm going to say files dot, or maybe you can say dot slash files dot zip like this to say work directory somewhere here. So I'm going to copy that right there just to see if that really works. To find it out, again, you are building an image. That means you have to repeat the same process again, So again, you will have to delete that image. So sorry, delete that container first. Then you have to delete that image, Again, you will have to build that image one more time. Where is that? Where is that? Here it is. Build the image. Once image is built, you are going to create a container out of it. Again, there is no point of checking the output because output is going to work. We haven't changed that. But now I'm going to go back and say docker container exec. If you can recall that command, that is going to be used for executing a command inside the container. -id, the container name is my container, and the command I want to use is bash. If I say ls, you see files.zip. Has it copied? Okay, it has not extracted. Probably this is not tar file. That's the reason. It's a zip file. That's the reason why it is not. But if it is a tar file, it would have extracted it. It's okay. So we have copied that here. It should have extracted it. Maybe I should have used a zip. Instead of zip, I should have used a tar file. It would have extracted that file right there inside the file, but it's okay. The only difference between add and copy is this. One is able to download the contents from URL and can extract the contents of archived file, not the zip file, archived file. I should have used a tar there. And the other one will not be able to do it. But both of them are used for copying the resources from source to destination. And when I say source in this case is nothing but the local machine. So this is going to be a local machine. So remember, this is the local machine and destination is always going to be the container. So this is going to be the container. So the common factor between both of them is like both of them are used for copying the resources from source to destination, where the source is the local machine and where the destination is always the container machine. So let us see, let us see the difference between these two only from these 2 points. One cannot copy the content from URL and cannot be used for extracting the archived file to the destination. That's the only difference. Otherwise, both of them can be used interchangeably. So that's an add or copy command. Now using this, we can build a simple application. Now what I'm going to do here is I'm going to stop this and we'll create a very simple example of it. This is something which I shared with you earlier today. That's the same called cluster.zip, the one which I gave you. Anyway, so coming back here, I'm going to go back and create a new directory and see what we can do there. First, I think that Docker, the one which the container which I started last time is of no use to me. So I'm going to stop that container and I'm going to remove that image as well. That image is no longer needed. Let's delete that image. I'm going to come back outside this directory and create one more. Let's say this is going to be my image2 directory. Okay, it's very simple example. Let us see if you can understand that. So I'm going to go back to that image2 example and imagine that I want to let's say write a Java code, and I want to compile the Java code there and I want to execute that code there. See the problem and see the solution. Again, everyone pay attention. Let me see if I have that image with me or not. Do I have that image? No, I don't have it. Let's imagine that I'm going to use a simple Java file or simple Java code in order to compile it and run it and see whether we can do it inside the container. This is my code. Let's say test class, test.java. Very simple code. I'm going to say public static class. This is going to be a, what's the name? Class test. That's it. Right inside it, as usual, public, static. Why static here? It's not needed. So public static void, I'm sorry, void main, and right inside this, it's going to be, sorry, a string args, which is an array. And right here, I'm going to say system.out, sorry, system.out dot print ln, what the hell, print ln, and I will say hello world from Java. As simple as that. So this is a very simple Java code. I want to try this code on my machine first and see if I'm able to do it. If I can, I want to put that inside the container that will be my Java applications container, and we'll give it a try there. Okay, so let us see how it can be done. You can't see that on portal. Rahul sir, can you please see why Kalpesh is not able to see it? Yeah. Okay, you are from UK. Very good. That's one thing. 1 second. Kalpesh and others who are not joining from India, for you people, we have one more option. So I'm going to tell you that right here. Just give me a second. Forgot that IP address. So those who are joining outside India, because it's a time zone problem, you can use this URL. Oops, sorry. I'm going to put that for everyone. So those who are joining outside the India, I think Kalpesh, you are joining outside India, right? You're joining from UK, I guess. If you are, then use this URL, the one which I sent you there. Use the IP address colon 8080. So I fixed that problem there. Probably you can use that and see if it is giving you the utility there. Okay, just confirm whether you can. You should be, because the time difference, it might not show you the result there. So hopefully if you use this URL, login is same, there is no change. Just log in with your credentials and see if you are able to access it. Okay. Okay, now coming back to this one, this is where, yeah, sure. So this is where we have written a simple test.java code. Let me come back to my command prompt and say if it is Java says not installed on my machine. Oh, Java says not installed on my machine. Now what do I do? Nothing to be worried about. I'm going to use a Docker and then we'll run that application there. Then we'll compile and run that application there. See if it is possible for us. To do this, I'm going to go back and see if I have any JDK version available here. So hopefully there is Oracle JDK or maybe Java SE JDK, or there are a bunch of options available. I guess it's better we can go with the Oracle JDK here, because something which is available here, or we can also go for Open JDK, no problem. I mean, we can also go for Open JDK as well. So not a big deal. We can go for Open JDK, that's better. So we can use this Open JDK and see if we can build an application inside it, inside the container, and we can run that there. So hopefully there we are supposed to use the Open JDK here. It says Open JDK 7. I'm going to use Open JDK 8. That's better, Sachin, it worked for you, right? Very good. It worked for you. That's good. Kalpesh, the link will also work for you. No problem. That's good thing. Exactly. That's the reason why we have created this separate link for those who are joining outside the India. Anyways, coming back here, I think I want to build this application and I want to test this application, but I need Java SDK on my machine. I don't want to install this on my machine, and that's the reason why am I going to create maybe a container out of it. But to create a container, I need an image. To create an image, I need a Docker file. So there we are. Let's see how we can do it. I don't think I have that JDK file, JDK image on my machine, which I can confirm that by saying Docker image ls. I do not see any open JDK there. So by the time I'm writing the code, I'll come back here on my command prompt and say Docker image pull, maybe open JDK. So that's where you're going to put the code there, or maybe you can put the command there, right? I should have done that. I'm so sorry for that, guys. Forgot to put all of these commands here as I promised last time. So what I'm going to do here is I'm going to open this inside my code. This is where I'll keep on adding the commands. So there is a file I'm going to create here called as commands.md, and there we will start adding the commands. Okay. So this is going to be bash section, and right here we'll put the command. So this is where we are going to download the OpenJDK there. Okay. Next, I think OpenJDK must have got downloaded on my machine. Let me just check this quickly. Image ls, wow, OpenJDK is now installed. It's almost like 486 MB. Exactly. Now, oh shoot, I should have gone for, just a second guys, don't do it, don't do it. I don't want to go for this image. I'm so sorry. OpenJDK, because we wanted to use OpenJDK special version, special in a sense. If we don't do that, it is going to download the latest version. I'm going to download OpenJDK 8. So this is the way you can do it. Name of that image, colon the tag. Tag is going to be the version I want to download. So instead of saying only OpenJDK, it's better we can say OpenJDK colon 8. Otherwise, it is going to download 15 or 16 or 17 or 18, whatever is the latest version available there. Anyways, it will get downloaded. By the time I'm going to go back, I think it got downloaded successfully. That's what I was wondering. It's almost like 500 MB. I know for sure. So this is 8, and this is something like 504 14 MB. It's okay. I'm not bothered about that size right now. So I want to get this done. How do I do that? To do this, I want to write the Docker file here. So again, we are going to start with from OpenJDK colon 8. This is my base image. Make sure that you are using OpenJDK colon 8 because we are going to use this runtime later. So in this OpenJDK, probably we'll have something like the Java C, Java, and all of these commands there, right? So see how it is possible for us and how we can do it. I think I'm going to go back here. Let's create a quick container out of it. Docker container, excuse me, Docker container run minus ITD. Should I say ITD? No, I think it's IT better. I'll say minus minus RM. Hopefully you recall. Minus minus RM means once we are done, it'll automatically remove that container. This is just for try purpose. I want to see whether the JDK utilities are available there or not. So Docker container run minus IT minus minus RM. Name is it doesn't matter actually. So this is going to be a test machine from OpenJDK colon 8. Don't forget to put the colon 8, otherwise it's going to download a new image for you. So root at the blah blah blah. I don't care. I'm just going to say Java minus minus version if it is available or not. I'm sorry, Java version. Oh, sorry, I'm so stupid. It's Java C, not Java. Java C minus minus version. It's not available. What the hell? Is Java C available? Yeah, Java C available. Oh, and it's not minus minus, it's minus version. And yeah, it's 1.8. That's what I was looking for. So hopefully I see the Java C is available. That means I can compile my code right here inside the container. So just confirmed it whether the things are looking good or not. I think the things are looking good. So again, going back here, go Docker image ls minus a, sorry, not image, container minus container ls minus a. Yeah, the container got deleted automatically. We did not put bash command for what? How did we get the login to terminal? Prabal, I forgot that. I didn't use a D here. If you say D, it is going to be detached. We are not going to get the command prompt. I just said IT. IT means give me interactive terminal, interactive teletype, and that's the reason why I got the interactive teletype or command prompt directly. And because I said rm minus minus rm, it's going to automatically remove it after I'm done with it. Okay, fine. So it's confirmed that image is the right image. So I'm going to go back here and I'm going to say that it's a work directory. Doesn't matter where I'm saying it. I'm going to put that in slash src. This is the directory which I want to be created. I wanted this one. I mean, I wanted to copy this file somewhere. So I decided to go with slash src. This file, I mean, this directory is something which I have decided, not necessary that you can use it. You can say my code, your code, whatever it is, doesn't matter. So maybe I can say src makes a lot of sense because it's a source code. I'm going to go with that src directory there. Now copy that file there. So copy means it's simply copy. The file name is test.java to dot. Dot means it's the work directory. So you know that copy is going to copy that file from my source machine to the destination, that's container. Now I want to build that code. How do I build that? We saw that now. So I want to build that code while the image is getting built. So run is the command which is going to be used for running your executable or maybe running your command at the time of building the image. So this is run, and I'm going to say java c test.java. Sorry, test.java. That's it. So this is where we are kind of building the code. So I'm going to say build the application, or simply I can say compile the code. It's nothing but to build the application. Right now it's just single command. Later on it can be anything. If it is a Gradle, it can be a Gradle build, or if it is kind of Angular application, then you are going to say ng build and so on and so forth. So this is where we are kind of running the javac command in order to compile my code. Now, once the code is compiled, you're going to get a test.class file in the same directory. Now, I want to run this when the container starts. So cmd is the command which is going to be used for running something when the container starts. So I want to run that application by saying java test file. Test is nothing but the class that I want to run. So this is where I'm going to say run the application when container starts. That's it. This is how I'm going to do the job. See what we have done here. We have said like we want to use this image for not only building the application but also running the application, because ultimately when the container starts, I want that application to run and give me the final output. Imagine that it's a big application. Right now it's only one file, but imagine it can be your real life big application where you are compiling it, where you are building it, and there you are going to run it. Okay, now what? So coming back here on my command prompt, and I want to build the image out of it. I want to create a container, and then I want to give it a try. So let us see. Docker image build -t. I'm going to again say, let's say my, or maybe let's say Java app, for example, Java dash app or Java underscore app, whatever. Java dash app is better. Dot is the context, and hopefully my image will get built. So Docker image ls, it shows that the image with that Java app is now created successfully. This is the second command I'm using here. So image is built. Now what? I want to create the container out of it. You know how to create a container, right? So you can say Docker container run -it. D is not needed because it just I want to run the application and see the output of it. So run it. Maybe I'm going to say again rm. You know what you mean by rm there. So probably if I say -rm, probably name doesn't matter. So even if you don't do it, it doesn't matter. I just want to create a container out of it. Container with that name, container with that image, Java app. I think if I say run, it's going to create the container, and boom, I got hello world from Java. So hopefully, if you have seen what has happened, we have copied that Java file somewhere here into my directory, into my container. I mean, into my image in the sense, ultimately it is now available in the container. And inside the container, using the javac file, we compile that test file. And then probably we have kind of executed that file when the container started. That's it. I mean, this is what we have done. And once the container started, I see the hello world from Java. Imagine here you are getting your application's output. Can be one single line, or it can be as big as maybe a website or a completely different application. So output depends on your application, coding depends on your application, but you know what? This is exactly what you would do in order to run a simple application there. What you are saying, Suman? If there is a situation where Java program send data to C++ program, let's say server program, in this situation for Java from OpenJDK, but supports a C++ program, we do write the from G++ in the single Docker file. No, see, you can have only one from in one image. So when we are talking about this from here, this from is what you are going to get a simple open JDK here. But if you really want to use that G++, or maybe if you want to run a C++ code right inside the same image, then we have to literally install the dependency for it. So probably I'm going to go back here and say, just a second. Oh, where is it? Oh, here it is. So this is the Docker command. Who's that? Amit, right here. Okay. So Suman, for you, look at this. So you can install all the other dependencies here. So let's say install G++. Because this is a Linux, I'm going to say run. Run means while building the image, copy the C++, or maybe GCC here. So maybe I can say this is Ubuntu, I know. So I'm going to say apt-get install GCC. So hopefully this is going to install GCC for me. So this is how we can copy, or we can install the required dependencies there. So probably, Suman, look at that. This image is not going to, it's not only going to have Java, but it also going to have all the GCC commands there. So you might run your C code, C++ code, and whatnot. So these things will be available there. I hope you are getting my point, Suman. So you cannot just use two from here. You have to use only one from, and based on that, you can create your own. So probably I mean, if you don't want to go for that, you can build one from Ubuntu directly. So I'm going to start with Ubuntu, and then I'm going to install GCC and OpenJDK. That is also fine. So you decide how you want to build it. It all depends on you. If you want to use the OpenJDK, which is created by someone else, you can do it, or you can create your own file as well. If I look at that OpenJDK, and probably if I look at the latest tag, maybe or 8 tag, for example, it's better we can just look at the description and see, where we can see official images repo. That's library JDK. Let's see. That's the one. Maybe this is, hopefully, yeah, that's okay. I can go back to the code here, and probably I can find the Docker file for all of them. Let's say Docker file Debian, Windows, Debian. Let's use this one. See, this is the Docker file. So they have added the Docker file. I mean, they have added the Debian here, and based on that, they are also doing the same thing here. So somewhere you see there should be an apt-get command or apt command. You see here, apt-get update, apt-get install, no install command, bzip and zip, blah blah blah. Then hopefully it is downloading the Java. So basically, what they have done is like they have started with they have started with Ubuntu or Debian, and on top of that, they have installed all the different dependencies here. So Suman, you can also do it on your own if you really want to. Okay. So this is how we can do it. I'm going to use the OpenJDK for now, but if you really want, you can put this G++ command there. So GCC is going to install everything there. Okay. So probably this is going to be the case. What is the difference between the run and CMD? Deepak, the major difference between run and CMD is like this is going to be executed while building the image. While building the image means it's going to get executed only once. While this command, whenever you say CMD, whatever you mention after that, it is going to get executed every time when container starts. Remember something what I mentioned earlier, container is made to execute one and only one task, and that one and only one task can be supplied here with that CMD command. So probably Deepak, so this is the one Java test is my only command I want to execute inside the container, I can supply that by using CMD. Whatever you feed to that CMD will be executed when the container starts, and whatever you feed to that run will be executed while building the image. See, building image will be done only once. Container you can create as many times as you want. So whenever you create a container, the program will get executed every time. But whenever you build an image, it is just going to compile that Java file only once. That's how we can do it. Okay. Arshit, is there any difference between CMD and a CMD Java test? No, there is no difference. You may say something like this, or you may say something like this. It all depends on you. You can say Java C and then test.java. You know, few people like this way, few people like this way. It all depends on you. So both of them will represent the same thing. Both of them will do the same thing. You can use CMD like this, or you can use CMD like this. It all depends on you. So this is Java and this is a test. So it's like you are kind of executing this file. I'm so sorry. We'll have to use that command here. Maybe you can say shell, sorry, sh minus C, and then you can say Java and test. So you can say something like this, you can say something like this, and you can say something like the one which I showed you like this. All of them will give you exactly same behavior. I personally like this way. I don't want to use that, the command bracket, I mean the square bracket every single time. And that's the reason I prefer this. But again, you may use square bracket, consider each command, I mean each part as separate string, and then you can pass them as square bracket or array of strings, and then you can pass that to the run or CMD command there. Okay. There is no significance. It just, you can use this style or this style. Both of them will do exactly same job. I hope, Harshit, you must have gotten that right. Yes, that's right. Robin, getting below error, failed to solve the front end Docker file, failed to read the Docker file, blah, blah, blah. No such file. You are in the wrong directory. So, Robin, make sure that when you are opening a command prompt here, make sure that either say ls or dir and make sure that you are in the correct directory. Probably I'm in the wrong directory right now, or I'm in the wrong terminal. I think this is where I am. Say ls or say dir, depending on operating system, and make sure that you are inside the same directory where your Docker file is. Otherwise, you will get that error. Okay. Harshit, if there is no difference, then why the ways are provided? See, it's like whenever you want to do a multiplication, you know that multiplication can be done directly. Let's say 2 into 4, I'll get the answer as 8. But you know what? 2 into 4 can be done like 2 plus 2 plus 2 plus 2. And again, you are going to get 8. There are multiple solutions. There are multiple ways. There are multiple, things you can do for achieving your goal. Which one you want to choose? It's up to you. So Harshit, the simple example is if I want to print, let's say, hello world twice or hello world 5 times on console. If I'm writing, let's say, C code, then I would say printf hello world, printf hello world, printf hello world, printf hello world, printf hello world. In a sense, printf hello world can be written 5 times and it's going to print that hello world 5 times. Or I can run a for loop and I can do the same job for, I mean, I can do the same job by using a for loop and everything will be exactly similar. The output will be exactly similar. Someone might say, no, no, I want to use a while loop. Of course, you can go do that in the while loop and still it can be done. So there are multiple ways to do that. Again, choice is yours. Okay. So Harshit, while giving the options, Docker has provided a couple of them. Which one you would like to use? It all depends on you. You choose which one you want to use. Both of them will give you exact same output. Okay. So that's fine. I hope Harshit that I mean that I could convince you that there are a couple of options and the choice is yours. Choice is literally yours. You decide which one you want to use there. Okay. Okay. So choice is yours. You can use this one or this one. I probably use this one. If you want, you can use this one as well. Doesn't matter. I will use this pattern, but not in Docker. I will use this pattern in Kubernetes. Why? Maybe somewhere I would like to use that in YAML instead of using it in a Docker file. So that's the reason I'm kind of reserving this style for for Kubernetes later. Okay, so seems like the things are looking okay, and I got my application executed here. I got the output as well, and you know what? I see that everything is looking good. The only problem, the only issue is, can you see that? I wanted to run a very simple Java application, one file Java application, and my God, look at that! It's almost like 514 MB image it has created. Can you believe? Just a single Java file, and I wanted to execute that inside the container. And to create that container, I'm creating an image of 514 MB. Are you kidding me? It's too big. It's too big. So what happens here? So probably if you pay a little bit closer attention, we are kind of building that code by using Java C, for example, and we are running that code inside the container. So probably what am I showing you here is a simple example of building an application and running an application. See, building an application will be done only once, but running will be done as many times as the container starts. And that is where I want to kind of separate these two steps into two different stages. And I want to build something called as a multi-stage build or multi-stage Docker file or multi-stage builds. What do you mean by that? So I'll show you an example and hopefully you will understand. A multi-stage build is the one with which we can separate the building and execution of the code into different kind of stages so that our final image will be a lot lesser than what we are having right now. See, the current version is 514 MB. Can't believe that. One Java file I want to compile and run, and it is creating a size of almost like 514. And do you know why the 514 is as good as you are using that OpenJDK? Precisely, if you just look at that image inspect command, you will understand, or image history command, you will understand why it is that big. So this is a Java app. You know what? These are all the existing layers. I didn't do anything other than that. This is the only command. This is the only layer. You see, these are the only layers, not one, but these, okay, let's say these are the only layers I have added on top of JDK. And these are negligible size, negligible layers. You know, one is almost, I mean, two of them are almost like 0 bytes. One is hardly 121 MB, where it is kind of copying this file, test.java, and it's kind of building it. So it's going to be something like 423 MB. It seems like it is adding that .class file and other stuff there. That's it. It's just 101, 121, sorry, plus 423, almost like 4 and like 544 bytes we have added on top of the OpenJDK. And that's why you see OpenJDK is 514, almost 514 MB is carry forwarded inside the Java application. My God, can you believe that? I mean, I certainly cannot accept it. Imagine, see, ultimately, when we want to use that image inside the real cluster, inside the real application, inside the real Docker container, if I want to create a real Docker container, I have to download that 514 MB, you know, which is not acceptable at all. So one of the best practices of creating images is you try to minimize the size, and that is the reason why we are looking for this functionality called as multi-stage build. Okay, what are you saying, Tushar? Why it's missing in the image column for bottom layers? These are the missing columns because you know what, when we downloaded them, most of them are kind of you can say clubbed into one. So it's not like it is keeping them separately, it's kind of merging them together. This is a docker kind of, you know, merge different layers into one so that it can optimize the build. So that's what it is doing. So it's kind of adding those layers, or you can say referencing those layers from the below layers. That's why it's not able to find it. It's perfectly fine. So this is while it is building it, but once it is available, you're having the multiple layers there. So those layers are kind of referenced here. This is the last layer you can see which is available there, which is kind of referencing the below layers, and not all of them are available. Maybe they must have kind of squeezed into one of them. That's the reason. Exactly, it's a bundle of layers or a collection of layers, and those are kind of squeezed together to create a few extra layers, or you can say few you can say few squeezed layers or few compressed layers, just to optimize the file size. Here we can see the command with empty bracket. Yes, exactly. You see, you do it with this way or this way. I mean, I'm doing it in this way, but you see that ultimately it is doing the same job here. You see, CMD blah 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 blah. So it does exactly same thing. So why should I put my efforts? If I do it in this way, it will always do the same job here. Anyways, this is how it is going to do the job. So that's the reason. You know what, now the time has come, and now we want to build a simple Java application into something called as a multi-stage build. Little bit advanced topic, but hopefully you will understand this. First, I'll tell you the concept, understand the concept, and then I'll show you a kind of a demo of it. The demo is pretty kind of simple if you understand the concept behind it. Okay, this is used, this strategy is used when the build system is complex. When I say build system is complex, right now it's very simple. It's just one single command, let's say java c test.java. But in other type of applications, you might have different build environments or different build procedures to create final application, and then you want to run that final application towards the end of it. So sometimes, rather these days, most of the times, the build system is complex. It optimizes the Docker file, and it keeps them easy to read and maintain. That's the reason multi-stage builds are used. It helps the size of image very low. I said low, but it's very low, and you will compare it and you will see how low it will be. It helps avoiding the avoid to multiple Docker files. Now, what do you mean by that? I'll explain that in a second. And it creates no intermediate images. Now, first understand the concept here. The concept is like this. When you are saying like you want to create a final container or final image, this is how you will do it. You will first write the source code. So maybe I can say this is where I will write my source code. Again, this source code is depending again on your requirement. It can be a C++ source code or a Java source code or HTML source code or whatever it is. I'm just going to say ATC right now because the list is quite huge. So you have got the source code. Most of the times when we are writing code or when we are using let's say Java like languages, it's not possible for us to directly execute the Java file. It's not possible to execute the C++ file, or it is not executable. It's not possible for me to execute the source code file. So we have to build this into an executable, and that's where we use a process. We call it as a build process. This is called as building the code or build a stage. Now, when I say a build stage is nothing but, convert. Build stage literally converts the source code into executable. I don't say executable. I want to say something like a package. Into a package. Into a package. For example, let's say you are writing a simple Android application. Let's say this is going to be an Android Java application. I'm just giving an example here so that you can understand difference between compilation and building. So when we are using a Java application, for example, not only in your code you will find the Java files, but also, there will be a Java files, but there will be XML files, plus there will be, let's say, JPG files, plus there will be some other files, let's say maybe JPG files, or plus .aar files, and so on and so forth. Ultimately, we have to pass all of them. We have to compile them, or rather we have to double compile them if it is an Android for a Dalvik virtual machine and stuff like that. And finally, we have to create a package called as .apk file. So probably, why I chose this example, because I guess most of you are using Android, and if you are using Android, you are familiar with this extension .apk. Stands for Android package or Android's application package. So ultimately, it's going to build the entire process, or it's going to build the entire application into something like an APK file. Just give me a second. If I'm not mistaken, Hopefully, this is, I mean, just for your reference, this is, oh, sorry, not that. My bad. My bad. Not this one. Mm, where is it? Do I have it? I guess I had that somewhere. Ah, here it is. So I just said that, this is the kind of a build system, or this is something like it is going to build that all of these things into one APK file. You know what? Behind the scene, it is this complex process. So this is an Android. I mean, fortunately, I use the Android development. I mean, I do the Android development as well. So you can see that this is how the Android application gets created. Finally, this is where you will get the signed APK file, which you can put that on somewhere in the Play Store, or maybe you can put that on your simply like a desktop. This is the Android's APK file build process. It's very complex, but you know what? This is the build process. This is the build stage. This is a one stage where you want to build your image, and once the image is built, you want to finally run it. I mean, not like APK file I want to run inside the container, but let's say a website, or let's say a kind of a complex application you have built and you want to run inside the container. So this is another step called as execution step. Execution stage or execution step. So if you pay closer attention here, we have got two different stages here. Stage number one is like a build stage, and stage number two, it's like execution stage. Execution stage is where we are kind of executing the code inside the container, and the build stage is where we are building the code inside again one image. This one has to be done inside an image generally, because it's going to be done only once. So this is where we are going to say inside an image. I'm so sorry, it's inside an image, and this has to be done mostly inside the container. So as you create container, the container is going to execute your application. This is how we generally do it. So if you are having complex build system, you will create an image, a separate image for building the process or building the code. And then once the code is built, I mean, you just use only one image. Let me add one more kind of a blank image here, and let me show you what generally can be done here. So you create a Docker file here. This is the Docker file for building an image, sorry, building a package. This is the Docker file where I will write the code for, let's say, building the application or building package, executable package, for example. And maybe I'll upload it somewhere so that, once it is uploaded, I can create one more Docker file, download it from somewhere, and then I will start executing it. So Docker file, and then, I will simply use it for execute purpose. That's it. So I'll have to create two different Docker images, one for building it and then second one for execution. If you pay attention to our code right now, we have one image for building the application, and in the same image I executed the application as well, and that is the reason why we are having the size almost like 514 MB. If I want to run this application, it's going to be very simple. I mean, execution should not be maybe execution do not require JDK there. It's just a JVM we need to run the application. So instead of running, or instead of creating a whole image of 514 MB, I would rather choose small image in which I would create, or I would run that Java file there. And that's the reason why am I going for two different Docker files, one for building an image, second one for executing a code. I mean, that is also an image, but that will just execute the code. That's it. If I don't know how to do that multi-stage build, if the multi-stage build is what something you are missing, then you will end up having two different images. One will build the package when you create a container out of it, and second one will run that image or run that container or run that application inside the container when you create that image here. So this is generally the way we do the job when the build system is complex. But again, you are in Docker. So Docker says you don't have to do that. You can merge both of them together in order to create one final small sized image with multi-staged. Multi-stage in a sense, you are going to say that from here to here, it's going to be, let's say, stage one. You can say a build stage, for example. You can say stage one, and from here to here, you can say stage two. So just copy the contents from here, probably from here, put them here, and copy the contents of this into this. That's it. So ultimately, the stage one will be building, and stage two will be execution. As simple as that. This is something called as multi-stage build. Multi-stage build will have one stage generally. I mean, not one stage, you can have multiple stages to build the application, and finally one stage to execute the application. Execution and building, if you put them inside the same image, the image size is going to grow like a hell. You see here 514 MB. So we want to split that into two parts, building and kind of execution here. So how do we do that? This is what is going to be shown in the next demo. I'll show you how we can build a better image out of it so that we can create small sized image for small sized code. Okay, so how do I do that? To do this, what I'm going to do here is I'm going to show you first a small demo. You can understand that. I think I should have done that, but it's okay. Forgot to do it. So Oracle JDK download 64-bit Mac. That's it. Okay, just a sec. I'm going to download it right now. So Mac OS X won't take a couple of more than a couple of minutes, hopefully, so that I can create a .class file right here and then do the job. Thank God. Thanks a lot, Chrome, for remembering my username and password, because I was really not able to recall that. So hopefully it is doing it. On your machine, you might be having it. So maybe you can compile that code on your machine and put that finally on the last machine. I mean, this is what, how much? It's 205 MB. I don't think it's going to take more time. Almost like 3 MB. It's an Oracle site. Can't help. Just give me a minute. Font is very small. Which font you are saying? Like Deepak, which font? The browser font or the Visual Studio Code font? VS Code font. Which font you are saying? Deepak? Browser font. It's okay. Browser is something which we don't have to bother about, but still, let me see. Oops. Let me see here. Okay. That's okay. Hopefully that is fine. There is nothing to be shown here. This is nothing to be shown here. Nothing to be shown here either. I'm just going to go back and do it this way. Okay. So probably that's fine now. Hopefully. Okay. So just wait for a couple of seconds. Almost done. 6 seconds, 2 seconds. And done. I'm going to do that. I'm going to do it right now. It's going to take hardly a minute for me to do it so that I can show you the final image. How much size will it be just to execute the code? Right now we are building that code. That's a reason. Apple Watch. Okay. So we are building the code, and that's the reason why the entire image is of 514 MB. So hopefully I don't need that. Just delete it. I can download it whenever I want to. So that's okay. So I'm going to go back here and say this is where image 2. This is where I'm going to say Java C test.java. I could not do that last time because I was not having the JDK there. Now I'm having the test.class file. So I want to create a container out of it so that I can run that test.class file here. How do I do that? Check this out. What I'm going to do here is, this is what my Docker file. I'm going to just put an extension here. Extension in a sense, I'm going to put a new file there saying Docker file. This is the old solution, or maybe I'll say dockerfile.old. I'm going to create a new Docker file and say this is dockerfile.execution. So this is where I want to execute the files there. So how do I do that? Before I do it, I'm going to show you a simple example of it. You see, when we are saying Docker image ls, I have one file. I'm having one image called as Alpine. Alpine is hardly 5.58 MB, and this is the smallest Linux. See, ultimately I need an operating system to run my code. So instead of going for Ubuntu and making my image size large, see, even if I go for Ubuntu somewhere here, it's almost like 72 MB versus if I go for Alpine, it's going to be almost 5.58 MB. You see the difference here. So what I'm going to do here is I'm going to start creating a container here, oh sorry, image here from Alpine. That's very simple. Now Alpine will not have any JDK installed. I don't need JDK. I want to run the code, so I don't need JDK. I just want to say install JVM. I don't need JDK because JDK is required for compiling your application, not running your application. See, I already have created a dot class file here. I just want to copy that inside this and want to run it here. So how do I do that? So I'm going to install this here. How do I install it? I don't know. Maybe if I just go back here and say Alpine install JVM or JRE, but JVM is nothing but a JRE. The package here is JRE. So there is a APK command we can use here, and then you can say run APK add open a JDK blah blah blah, or open no, not open JDK blah blah blah. I want to use JRE, not open JDK. Sorry, this is JDK. I want to run JRE. Open JDK 8 JRE. That's what I'm willing to install here. Exactly. So let's go back here and say apk add blah blah blah. Apk add means it's going to be similar to if you are coming from let's say Ubuntu Linux. This is as similar as apt-get install openjdk JRE. If you are coming from CentOS or Fedora, or maybe not Fedora but CentOS or Red Hat, it's like yum install openjdk. And if you are coming from Fedora, then dnf install openjdk JRE. So in Alpine Linux, this is the way we can do it. Apk add openjdk JRE. That's it. So install JVM. I'm going to say JRE because JRE is going to install JVM for me. So this is what I was willing to do it, and that's it. You know, the next one is where we can create a work directory. We can say this is src, and look at the difference. I want to execute the code. I don't want to use the original code here. Praveen, apk command is used for installing an application in Alpine Linux. This is the smallest Linux possible. So this is the Linux operating system, 5.558 MB, and we are installing OpenJDK here. apk command is used for installing something inside the Alpine. That's what I said. This is for Fedora, this is for Red Hat and CentOS, this is for Ubuntu, and this is for Alpine. So work directory src, copy test.c.class to dot, and here I want to run the application. To run the application, I just need Java command, and I'm going to say test.class. See how simple is that? This is where I'm not copying the original .java file. I already have compiled it on my machine to save the image size, and then I'm just copying that test.class file into this image. Let us build this image and see what happens. I change the file name to dockerfile.execution. Can we do that? Yes. The only thing you have to change here, I'll show you. Docker image, just a sec. Let me put a couple of commands here. So I'm going to say docker image build -t. I'm going to say Java app-1. This is my first image after modification, and this is where I'm going to say -f for file name. And if it is not Docker file, then we can say -f dockerfile dot whatever name you have selected there. So I'm going to say dockerfile.execution, whatever it is, minus image build, build an image from Docker. What the hell? Docker image URL path. Exactly, it should have. Okay, it's not needed. Okay, fine. Error install load build definition from Docker file. What the hell is that? Let's see. From Alpine, that's right. Run apk file, work directory, copy this, and cmd. That's right. That's correct actually. Let's not go into the execution. Maybe that's where it is looking for. That's fine. I'm going to go back here and say same directory, same command, just with the dot. That's fine. It is building that image. Look at the image ls, and this is the file, or this is the image we just have created. This is the one which we have created earlier. It was almost like 541, I'm sorry, 514 MB, and the one which I just created here is almost like 87 MB. Look, Docker container, I'm sorry, container, I'm going to say run minus IT. D is not needed because I just want to run the application. Minus minus rm, and this is going to be java dash app dash one. It also show the same thing here, cannot find or load the class. Why the hell? Oh, I'm so sorry. We have to say dot slash src. My bad, I should have gone for that. Build that image one more time. That's fine. And then if I go for executing this command, probably it is going to show me the same class. I'm so stupid. I need to say test. Sorry, this is where I want to run the code. I just have to say the class name, not the dot class extension. My bad. Let's build the image one more time and then execute this. And you know what? You will see exactly same output. If I create the application, sorry, if I create the container from my old image, I still see exactly same output. See, the output is same. Image, there is Java app 1 and there is a Java app. And look at the difference. Image ls, and you see that the image open Java, I'm sorry, Java app older version, it's almost like 514 MB, and the one which we have just created right now, it's 87.9. Now, why is it having those three versions? Because I built that twice. So every time it has created a new version there. This is the size difference. Look at that. It's almost 5 times, even more than 5 times bigger than the one which we have just created here. This is the optimized version of it. Look at the intention behind creating this image. The intention behind creating this image is to finally execute my code. That's it. I don't want to build the code every single time. I want to run the code every single time. Building will be done only once. You can build it inside your code, inside your file, and you know what? You have to do it every single time, and unnecessary, it increases the file size because it has to include JDK here. But if you are willing to do it on your machine, then you can build that .class file on your machine and create a simple version of it. And then you can say that, hey, this is where I'm going to use Alpine, make the size a little bit simpler or smaller, and that's it. This is the way we can do it. You see the difference now. It's almost like 90 MB with this image, and it's almost like 514 MB with this image. So it is not including JDK. That's the reason the size is a little bit smaller. So that's how we can create those two different Docker files if we don't know how to do that with multi-stage Docker. How to go for multi-stage build image. Okay, this is not the final solution, guys. This is a kind of maybe you can say execution code. This is not what I'm going to go for. I'm going to go and combine these two together. In a sense, I want to copy this part. This is my build part, and I want to copy this part. This is my execution part. So this is where I'm going to say Docker file. This is my final version. Literally, I'm going to copy this code and put it here. And literally, I'm going to copy this code and put it here. What I said earlier, I just want to copy these two into one single file. So I will call this part as my build process and this part as my execution process. We don't need to do this. We don't need to do this. This is the simple part, as simple as that. We don't need to put these comments now because these comments we already have added last time, and hopefully you must have understood this there. That's it. Unable to prepare the context, Docker file.execute. Probably Kuldeep, make sure that you are in the same directory and then give the command. So probably that is the reason why you are getting that code there. It's better you copy that file somewhere, or maybe you can rename that file to Docker file for now. Right, Prabal, you can consider that as a QA and production version. Absolutely. It all depends on you how you want to look at it, but this is how we can do it. So I'm going to call this as my build stage, and I'm going to call this as my execution stage. And you see what I've done here. I've copied both of them together inside one single file. So this is where we are going to say build, and this is where we are going to see we are going to say something like an execution. So here we are going to build it, and here we are going to kind of execute it. Now, see the problem here. Now, when we are kind of doing this, let me go back here and say, add one more page for understanding purpose. And this is what we are doing right now. So understand this, guys. This is where we are kind of creating a bigger image. Maybe I'll put a little bit bigger, literally bigger. So here we are saying we are having two stages in between. So probably I'll say this is stage number one. You can call it as a build or you can call it as exec, whatever, it depends on you. And let's use completely different. Let's say this is the another one. This is the execution build or execution stage. So let me add that let me add that something like a build stage and execution stage. So what happens here is you are kind of writing the command and finally your application will be built. So maybe I can add a comment here and say build the application. Maybe, for example, application is available inside the /src directory. So this is where we are building the application and adding it into /src. Now, from this src, I want to copy the code and put it somewhere here. You see what has happened in previous one? We said that copy test.class. The test.class is going to get copied from this machine. I'm going to delete this file because I don't want to do it in this way. I want to create one stage to literally build the image. And once the image is built, I want to copy it from the previous image. I'm sorry, previous stage. And that is where we can say, maybe I can say from, this is what I said here, open jdk colon 8, I'm going to call it as whatever you want to call it as. I'm going to call it as a stage 0 or stage 1. You call it anything here, it doesn't matter. This is just a kind of, you can say a kind of a temporary name given to this stage. And then you can copy something from the previous stage into the next stage by saying copy. This is the command we have used, from minus from, and you can say this is going to be stage, what did I say here? Stage 1. That's it. You see, someone is accidentally muted, unmuted. Okay. So so you can say that from stage 1, from stage 1 means we are referring to the previous one, and then you can say this is my this is my stage name which we have just assigned in the previous stage, and then you can say this is my source and this is my destination. SD means it's a source and destination. So this source will not be your machine. This source will be from the stage 1. And from the stage 1 means it's really going to copy that from this src directory. And then it is going to copy it here. Probably this is something called as a multi-stage build, So this is called as multi-stage build. This is called as multi-stage build. So multi-stage build means you can have multiple stages here. So I'm going to call this as my first stage. You can say as stage 1, stage 2, whatever it is. You can call it as anything there. So it's all up to you, whatever you want to call it as. What it is saying, invalid parameter, blah, blah, blah. This one, it's okay, it doesn't matter. Even if you don't want to go for that, it's fine. I mean, you don't even have to go for the image name, the stage name as well. You can directly say 0 as well, doesn't matter. It's up to you. But I really want to give that stage 1 as the name. Maybe it's like as capital, that's why it's not working, or it's giving me an error, or it's giving me a warning saying don't do it, leave it, doesn't matter. So from here, this is important. From here, I'm going to say from which stage? So from stage 1. So this is where we are referring to. This is stage 1 and this is stage 1. So we are referring to this stage. From here, copy /src/test, because we have decided the work directory /src. This src is going to be from stage 1. So it will go back to the previous stage. It will copy that from this src test.class and will copy it somewhere inside this src. It doesn't matter. Maybe I can say this is going to be my app, for example. Here I'm copying it inside the app, and then we are executing that code here. Yes, Tushar, that's what I'm explaining again. This is my build process. This is my execution process. I'm combining these two together in multi-stage environment. In multi-stage environment or multi-stage build, we are having one stage where we are generally building the code and another stage where we are generally executing the code. Building will be done only once, and once it is built, it will automatically create the final version with this image. This is the final one. Whatever is at the end, that will be your final image. That will be your final contents. So this is where we can say from Alpine run apk blah blah blah. This is the work directory app. I'm going to copy from the previous stage, stage one, and then from this directory, I'm going to copy that test.class into the current work directory, and then I'm going to run that code Java test. Let us see what happens now. I think it's better we can just delete all those old images because those images are of no use. First, let me see how many containers are running. None. That's good. So I'm going to go back here and say image remove. That's Java app and Java app dash one. Delete both of them. Sorry, delete. And then we can go back and say ls. You see there are unnecessary layers here. No big deal. We are going to say image prune. Prune is the command. It's going to delete unwanted or orphan images. Orphan images are those which are not associated with any name. So these two images, I think dfab is removed, and 730t 7302 is removed. This is another new command you can see here inside your command list. So this is going to be docker image prune. Prune means remove orphan images. Remember that. This is another command. So I think we are now clean with those images. Now those images are gone. I'm going to create a new image here. See, docker image build -t. This is going to be Java app final, for example, dot. That's it. This is where it's going to find the final Docker file. So it's so fast. Let's see. Docker image ls, and probably it has created a final image of 87.9 MB, and probably I'm going to go back and create this Docker container and see if it is giving me the same result or not. So Docker container -rm minus it, doesn't matter whether it is there or not, it's okay. So it's not even needed. So what am I supposed to say? It's better we can say that -it docker container -rm it. Name is not exactly what you're looking for. It's okay. App. This is important. I'm sorry. Java app dash final. So hopefully, I'm sorry, who will say run? Oops. So this is where we are going to say docker container run -it blah blah blah, and you see that it is giving me exactly same source code here. So this is what exactly do you mean by a something like multi-stage build? I know it's a little bit advanced, it's little bit different than what we have seen, but this is really important concept. I personally had one question on this topic, multi-stage build. The question was similar to, shouldn't have even exposed this, but it's okay. So the question was related to this topic, which was asking me like, what will be the final image containing? Will it be having dot? I mean, in this context, will it be having dot Java file, or will it be having dot class file? And what will be the size of it? Will it be a small size or will it be a bigger size? So something similar question I faced in my exam. I mean, I should not tell you the exact question because of the NDAs. Again, you will see that when you sign up for exam there. So I can't tell you what was the question, but regarding the similar question, I can tell you right now. So what will be having inside the code, inside that final image? Will you have .java or will you have only .class? The answer is only .class, and the size is always lesser than the original image. Atul, what are you saying? Can we say that it will create only from stage 2? Absolutely right. It is going to build the final image from the last stage. Instead of saying stage 2, I'm going to say last image, last stage. If you are having couple of stages in between, this last one, it is going to start with. That's it. This is how it's going to do the job. Guys, do you understand what am I doing here? I don't know how many of you have understood this, but this is exactly what it is going to do. It will overwrite all previous stages. Absolutely right. It is going to build only the last one here. That's it. That's it. I'm going to go for one more small example. I know not most of you will understand this because I know for sure most of you do not know this, but still just look at it as a kind of a developer here. So I'm going to search for something like an Angular. I'm going to write a simple Angular application here and see whether it is going to do the job. Do I have it here? Angular. Wow, it's not there. Okay. Angular 2. Search for Angular 8 or Angular 10, whatever. Mm, do I have anything? It seems like there is nothing. Angular headless CI. That also can be used here, or we can build our own. It's not a big deal to do it, or we can build one by using node. So it's better we can just use a node here and see whether we can do it. So this is the node probably, and if I want to create an Angular application, let's see whether we can build one by using the multi-stage build. Okay, so hopefully I would need 14.15. That's the latest version of it. Angular spelling was wrong. That's what I was wondering, how come it is not showing me anything. But anyways, Angular. Anyways, it's giving me the ng container. This is not something I'm willing to use because it's updated 2 years ago, so it's of no use. Let me see, recently updated. This is Angular CLI. Angular Docker, blah, 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 blah. Starting Angular free, explore ng version, Angular. Which version are you running? ng version 1. Oh my God, it is too old. It's too old. Node 6.0. It's too old. Leave it. We'll build our own. It's not a big deal. So probably I'm going to say this is a Docker file. I'll keep it as it is. And let's go for a new example here. So let's come out of this. I'm going to create a new directory, image3. I'm going to go back here inside this image3, and I'm going to create a new application here. So ng new app 1. Those who are having it, you can. Otherwise, just look at it as a developer. It's a very simple example. I'm not interested in doing anything like this. By the way, being DevOps engineer, not necessarily every time you will understand the technology code. Build Docker image is something that you should be expert in. Building something like images and container will be your job. Writing code will be the job of developer. Developer is getting paid for it. So developer will do that. You will simply use it and probably write the code there. Sorry. I think I'm going to go inside the app and we'll do it. Now let's open this. And let us see whether we can create a simple Docker file and simply create this application there, So Docker file, sorry. See, by the way, if I look at the size of it, so if I just open this and look at the size of it, it almost goes in 200 to 300 MB. It's more than that, 400 somewhere, 325 now, almost like 400, or let's say almost like 300 MB. So if I want to build a final image, the final image will not be built like this. The final image will be built by using ng build minus prod. That's it. This is the command which is going to be used for executing okay. So this is the command ng build minus prod. It is going to build my image or build my website, and then you see the final size, you will laugh at it. This was 325, but when the application is going to get built, this is the final version of it. And if you look at the size of it, it's hardly 192 kilobytes. See the difference between building and building and after building. Before building and after building. Before building it was 325. After building it has come down to almost like 192 kilobytes. Now I'm going to build a very simple image for this one. So to do this, I'm going to say from node 14.15. I guess that's the latest version. And if I'm not mistaken, I saw that somewhere there. So we can use that and we can try this now. 14.15, it's already available here. So hopefully 14 or 14.15. I think that is going to be fine. 14.15, this is okay. So from 14.15, first I'm going to install, I'm going to install ng utility here because it's not going to be there. It's not going to be there. So we'll have to install it. So run npm, npm install -g at the rate, -g for global at the rate angular /cli. And we can easily find this command right here by saying angular.io, getting started, and there you will find the command npm install -g angular blah 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 angular /cli. That's it. Now build the application. How do I build the application? I told you it's going to be ng build --prod. That's it. Oh, I'm so sorry. We'll have to copy the contents, right? Copy the code in the image by saying copy everything from there into this one. So everything in a sense, you're going to copy every single thing, all the directories, all the folders, every single thing will be copied here. And then you are going to say ng build --prod. Oh my God. Run ng build --prod. That's it. This is going to be considered as my, let's say, stage 1 or build stage, whatever you can call it as. Next, I think this is where we will start with the second stage or the final stage. That's it. This is where we are going to say from. This is going to be a website. When I say website, it's going to be, for example, HTTPD, So I want to copy the files, but, copy from stage 1. Okay. Maybe we'll set it to, let's say, work directory. We can set it here. Work directly /src. Doesn't matter where we are copying it. It's going to be important here. So /src/dist/app1. I want to copy this into /var. I generally would like to copy this from the Docker hub instead of making any mistakes. And this is generally the right way because most of the times images generally get updated and they might change the path and other things. Copy means we are copying the HTML file, these HTML files. So inside that app1, you will find the index of HTML and other Java files. So this is what we are copying. Copy ... means copying everything from source to destination. So that's what we are copying from my current directory to the container to the image there. So this is where we are copying, let's say, copy the built version of website. And finally, the same one, this is, HTTPD. So expose port number 80. And finally, CMD, it's going to be Apache CTL, -D foreground. This is what we already have done earlier, That's it, Apache CTL -D foreground. That's it. Let us see if that really works and if that gives me a kind of the image which I'm looking for. So let's see, build I'm sorry, why am I saying build? It's going to be Docker image ls. That's the last version we were having. I think it's better we can remove that. It's of no use. Java app final. I'm going to build a new image here. Docker image build -t. I'm going to say dot, and we'll say that. What do I want to say? I'm sorry. Maybe I'll say this is going to be Angular app dot. So it's installing that now. ng. See, it is building up. It's doing its job. It's building up. It's transferring the context, transferring all the files. Now it is going to install that. Then it is going to create the HTTPD. And if everything goes well, not sure, but if everything goes well, then probably it is going to, did you see that? It's the stage 1 by 2. Now this is 1 of 2 in a sense. This is the first stage it is executing right now. Once it is done with it, It is installing the Angular CLI right now. See, so it's going to install that latest version of ng. Still doing it. Very good. Now it is copying the entire source code from my current directory to the image. Now it is building the code. See, this is stage one, last stage, last you can say command, ng build minus minus prod. It is kind of building the website, building the Angular application to create the HTML version of it, to create the website version of it, generating the browser application bundles and blah blah blah. In a few seconds or a minute or two, you will see the final version built. Exactly, it is done. Now 2 of 2, copying this file, I mean all of these files into the htdocs, and hopefully it has done its job. So now time is there to check this out. Image ls Angular app. See, the final size is hardly 138 MB. Otherwise it would be the entire HTTPD. It's 138 plus the node application. I'm sorry, 138 for HTTPD plus node. Where is the node? OpenJDK Angular. Where is the node image? Okay, it must have downloaded on the fly, but almost like this is another couple of hundreds MB. So possibly when we are doing something like this, it is kind of doing this job easily. If I just say pull node 14.15, just to see how much size will it be adding into my image. If I would have not gone for a already exists, that's fine. So if I just want to say image ls, this is node. Oh my god, look at that, 942 MB. It would have gone for almost like 1.1 or 1.2 GB, but now it is hardly 138 MB. Let us give it a try. Not sure whether it will work, but let's see. Docker container minus minus rm, I'm sorry, run minus minus rm minus it, for example, mytd, because that's a website, minus p 8080 colon 80, and finally the application name is Angular dash app. It has created the container. So let us see if the container starts and if we get anything. It's port number 8080. So probably I'm going to go back here and say localhost colon 8080, and boom, you see this is an application here. This is an Angular application. Those who are coming from Angular batch, they can at least remember this part here. This is the hello world Angular application, and this we have created by using a something called as multi-stage build application, a multi-stage build process. Robin, how best image in stage one can be used in the other Docker files? No, you can't. If you want to do it, then you have to copy paste that stage everywhere. So probably if you want to create one more Docker file where you want to use this one, copy that code and put it there. You can't just refer one Docker file into another Docker file, So you have to do it in this way. Okay. So Robin, in that case, you can copy this one. And if you want to reuse it, it has to be reused only in the same Docker file. It cannot be across Docker files, So that's not possible, what you're looking for. Okay, so hopefully, guys, you're able to understand that, what I just showed you here. So what is your question, Tushar? What is happening in the background? Is Docker deleting the contents of other stages after build and then left only the execution stage? Absolutely said. Absolutely right, Tushar, what you said. While building the image, it does download every single thing. And when it downloads every single thing, it builds the image. But when it comes to do the finalization, it removes all of the cached images or all of the cached layers, and it just gives you only the final layers. Remember what I said inside that slide? It does not create the intermediate images. So no intermediate images simply means it is going to remove all of them there. I mean, all of the temporary files or the temporary images it has created behind the scene. Hopefully, Tushar, that answers your question, right? Robin, what do you say? Does that mean the two layers will be created into one stage and one for the other stage? Yes, both of them will be merged into only one. Rather, everything here will be deleted. Only the last stage will be kept. That's what you need to remember here. Okay. Yep. Who's that? Sachin. I think the Bamboo build server does exactly same task internally. Not only Bamboo, the Jenkins can also do the same thing, guys. I mean, what we have done here is like we are kind of building it and then we are kind of creating the final image. I would have done that using separate images by using Jenkins as well. But why to go for there if we do that right inside this single utility, Docker utility? That's the reason why am I telling you this. Okay. Vaibhav, what have you installed before Docker file for Angular inside image3 and app? Inside this, I mean, on my machine, I already have installed Angular CLI. This is the same command I used. And then I created one application by saying ng new app1. And then we have written something like this. Okay. Sachin, yes, exactly. Concourse, CloudFront. There are many different CI tools out there which are going to do the same job. But this is a little bit better than doing in Jenkins, because in Jenkins you unnecessarily will have to go for building it every single time when you do it. This is where I know it has to build only once. Execution will be always. Yeah. So that's a better approach when we are going for creating the images out there. Okay. Not 100%, but at least have you understood 60 or 70% of what we have discussed here? Remaining, you will have to do it on your own. You'll have to practice it in order to understand 100%. This is one of the important questions in your exam. Exam might ask you the question like, what will be the final contents of your image? Will it have node or will it have HTTPD? The answer should be HTTPD, because last stage is what it is going to keep, and remaining stages will be removed, will be deleted. That's what we said. No intermediate images. Okay. Anyway, so that's the reason why I said a little bit advanced topics, but that is what we have to look at for your so-called exams. Okay, Anshul, later please share the Docker files also. Of course, I'm going to share the entire directory with you. Don't worry. Robin, if it is internally deleting the base images, then how is it using the contents which is there in the first Docker image? Of course, it copies every single thing, and once it builds when it is building the final image, final stage, then only it does that. Didn't you see that when we were trying to build that image, it knew that there were two stages. You see stage one here, and then it says stage one, stage dash one. Stage dash one is nothing but this is the stage one, this is the stage two actually. Two of two. So it knew that there were two stages inside it. So even before it started running the code, it knew that right inside this image we were having two stages. It's very simple. There are two frames, means there are two different stages. So it uses all of them temporarily. Once done, it just removes those and then just keep only those layers which are necessary for your last stage. Okay, Robin, this is how it does the job. Okay, so hopefully you must have got the concept of it. That's fine. So hopefully now we are kind of done with this. Okay. When we have multiple stages in one file, yes, we have to write the multiple stages in one file, but finally when you are doing this the final job, then it's going to keep only the last stage. It's not going to keep it's not going to keep all the stages there. The only last stage will be there in the final image. Okay. Docker image, what do you say? Something like this. Documentation, blah, blah, blah. The shell from the exec command does not invoke the command shell. This means the normal shell processor, for example. It's okay. It doesn't matter, Harshil. When we are talking about this, both of them will do the same job. Believe me, both of them will do the same job. Ultimately, even if you are saying this, where is it? Apache CTL -D foreground. This has to be executed by one of your default shell. You do whatever you want to do. It has to be exactly the shell which is going to do the job, because unless you have the shell, you will not be able to do anything there. Okay. So probably even though you are saying this or even though you are saying this, both of them will do the same job. So you decide which one you want to go for it. And if you don't believe me, try yourself. I'm saying don't trust anyone. So it's better you try yourself. You will see that ultimately you do this or do that, you are going to do the exactly same thing. Your output will be exactly the same thing. Okay. Command to run this container, all, I mean, the same container, the same command, container run Java app, container run Angular app. What was that? So here we are, and hopefully this is the one. It's a regular command, guys. Nothing different. That's it. Okay, Tushar, in image2 Docker file, if it deleted the OpenJDK after build, how come it will be it will be able to use OpenJDK again in line number 11? Sorry, which one you are talking about? The previous application, right? In image2. What did you say on this one? Okay, you're talking about this one here, this one here, right? This is because of the JRE. Absolutely, got it. Good. Okay, so hopefully you must have seen this now. It's a little bit advanced concept, but you have to know this. There is no option. This is the difference between just studying Docker for the sake of studying it and studying Docker for your exam. This is the exam topic. Okay, so this is how we can go for multi-staged builds. Now, once we know that, again, couple of simple examples, how to save an image and how to load it when there is no internet, or maybe when you are not able to connect to Docker Hub, or how to export and how to import, and finally, how to share the Docker. This is something we already have seen last time. There's nothing to be worried about. So let me show you this quickly and see what exactly the image save and load means. Okay, so when we are talking about just sharing or downloading the images, we download them from Docker Hub. Yes, Tushar. We'll look at these two commands and then we'll take a break. Okay, so we can close this logically and we can look at some advanced container topics right after this break. Okay. So what happens here is when we are kind of downloading the images, we generally download them from Docker Hub. And when we say Docker Hub, this is one of the public repositories, where you can download the required images. But for that, you have to have an internet connection. So not every time you are going to have an internet connection, and in which case it will be difficult for you to share your images or download the different images out there. So in case of no internet environment, it becomes difficult to connect to the Docker Hub and download the required images there. Or probably I want to share my image with my client or with my let's say with my colleague, for example. Or maybe I have another machine where I want to do it, but on that machine I don't have internet connection. I can't connect that to internet because of some security reasons, for example. So how do you do that? How do you share your images there? So Docker provides a facility to convert your images to a tar file and copy them to the restricted environment where the internet is not there. Command is very simple. You're going to say docker image save my image minus o, something like a tar. And again, when you are loading it, you can say image load minus I my image dot tar. That's it. It's very, very, very simple. Give it a try on your machine as well. You can create a very simple example, or you can use whatever the default images you are having right now. Oh, the choice is yours. Maybe if I just go back and say docker image ls, I have that Angular app there. I can use it if I really want to. So I can say image save. There are two commands. One is the save and the other one is the export. Both of them are going to do the same job. So save whatever is the name of that image minus o. So it's going to be Angular. What was that? Angular app, right? Angular dash app. Let's say minus o. Let's say Angular app. Angular app dot tar. That's it. So it is going to create that Angular app dot tar. Wait a second. I don't think I should be creating here because it is unnecessary going to. Oh, it has done that. Wait. Angular dot tar. I don't want to do it here. Instead, I'm going to go do it right inside in my temp directory. So it will not go onto your server there unnecessary. Okay, so if I go back to slash tar slash tmp, I will see that file there, angular-app.tar. So if I open this file, if I open this directory, I would see that file. It's a tar file. It's almost like 141 megabytes. Fine. What I'm going to do here is I'm going to say docker image ls, and I'm going to delete that image here. So rm angular minus app. This is what I want to delete now. That's it. Oh, the container is running for that. So sorry. Container ls, we have to stop that or remove that container forcefully. It's 97c, for example. That's the ID I saw there. And then I'm going to delete that image. So this is where we have deleted that image. See this, I don't have that image here. So image ls will see that. I mean, it will show you that the image has been deleted. Now how do I load it? To load that image, I'm going to say save and load. That is the pair I'm going to use there. So load, what's that? Slash tmp, that's angular dot app dash star. That's it. I think, I'm sorry, I forgot to say minus I. That's it. And then you see, this is the same command I was talking about. Minus O for giving you the final output, minus I for input, and that's it. So this is a kind of a command that you are going to use in order to, just get the command, get the image. And do you see that? Now, I'm sorry. Now, hopefully, Angular app is back in, it's back in the business. So this is where we have deleted it, and this is where we have brought it in again by using the load command. That's it. You use this tar file. I mean, you can copy that onto your pen drive, for example, and then put that on other machine, and there you can execute the load command and get the image back. So when you are having a restricted environment, you can go for image save and load functionality. Okay. Any command to directly delete the container and image together? No, Prabal will have to we'll have to delete the container, and then we have to do it again for deleting that image. If I don't use minus minus force while deleting the container, is there any impact? It will not allow you to delete that container because it is in a started position, or it's a started state, So if the container is already started, how can you delete it? So you'll have to first stop it, So if you don't want to stop it, then you can use minus minus force for that. Can we create an alias here? Alias for what, Harshal? So we can use, yeah, of course, you can. It's up to you. If you really want to, you can create an alias there and you can do the job. Okay, not a big deal. But this is one way you can say the data or the image can be saved and can be loaded. Now, again, the similar thing, there is an export and import. I'm not going to do it in front of you. You can try your own because it's just the same command. Export the container name to an image. I mean, this is the way we can get the container to an image, and then you can import that image directly from that new image. That's the only difference. One is image to image, and this is container to image. Give it a try yourself. I'm not going to do that because it's one single command you have to run. So you can do it on your own, I believe. Now, this is something we already have seen, how to share the images over the Docker Hub. I showed you that demo last time. I think I should have deleted that slide, but it's okay. Doesn't matter. We already have seen it there. Now, this is something like a best practices. Remember this. This is for your so-called exam. So always remember, create a slim and a minimal images. Slim in a sense, those are having a low image sizes, So image size should be always as small as possible. Find an official minimal image that exists so that you will get a low sized image. Low sized final image. So if you want to create your own image, always remember, keep it as low as possible. Only install the necessary packages. Do not install everything. You remember the example I gave you, JRE. I could have downloaded JDK as well, but as per the best practices, always download only the necessary components. I don't need JDK to run an application. JRE is more than sufficient. Maintain the different images for different environments like development or maybe production. In the development, you can include the debug tools, and in the production, it will be small. We don't need any debugging tools there, so we can optimize the size. And finally, use multi-stage builds to create the lean production images, small production images, and that's what I just gave you a demo of. This is one of the best practices, or rather, these are the best practices when we want to go for building images. I hope that must have given you a complete picture clear, like what happens when we are building the images. That's it. Now we'll continue further with the volume, with the networking, few more advanced topics, and then we can see how to build our own, the cluster, Docker Compose, and stuff like that. But I think it's better we can take a break before, and then we'll come back, and then we'll continue with the rest of the topics. Will you come back, guys? I see already 30 people have already dropped off. Maybe it's going on top of head, I guess. So that's it. Are we going to cover the entry point and ARG command? Yes, not today, not in this week. We'll show you that example in the Kubernetes, because it makes more sense to see in the Kubernetes world, not right now. It's okay. Even if you do it right now, it will not give you the importance. But later when we go to Kubernetes, you will see the importance of having entry point versus CMD. What's the main difference? I'll show you that in the Kubernetes, okay? Okay, so let's see. We'll take a 15 minutes break in between, and then we'll come back, and we'll start talking about this. Yeah, better you put that on a WhatsApp group, Aniket. Not a big deal. Definitely. I hope you are there, guys. Yes, good. Okay, that's good. So let us continue and see what exactly the Docker volumes are. I mean, where we can use the Docker volume, how we can persist the data permanently, and what is an advantage of using Docker volume there. Okay, so let's see. By the way, if you can recall something, I said that Docker containers are mainly immutable. And when I say they are mainly immutable, you know, so you are not supposed to save anything inside the Docker, inside the container, because when you say when you are saving something in the container, when the container is gone, when the container gets deleted, or when it gets removed, you are going to lose whatever data you have added in that container. So it's very risky to save something inside the container. So if it is so risky, then I mean, how do I store the data? How do I persist the data? Because container may be running my application, and probably my application is kind of processing the data. So I'll have to persist it somewhere. Let's say this is a MySQL running inside the container. So if it is a MySQL, I still have to persist the data, isn't it? How do I do that? This can be done by using volumes. So let's understand this. When you are going for Docker storage, there are three types of Docker storage options you are going to have. One is called as a local storage, the other one is called as the persistent data storage, and the last one is called as a static image storage. Now, what is a local storage? This is the storage provided for the Docker images run. So probably when the Docker images are getting created, this is the local storage that will be given to you. Uses the storage drivers to read the FS layer from the container. So that is nothing but the layers, or that is nothing but the code, or that is nothing but the content you're going to put inside your image. That is nothing but the local storage. Again, when you create a container, it is going to give you exactly the same layers inside the containers there. Let's look at the last one first. Static image storage. Storing the images in the Docker registry. That means the Docker itself, I'm sorry, the image itself is a kind of the data. It is going to get stored inside the Docker registry. The image stored in the registry will not run unless the container is spawned. So yes, there is an option of storage, but it will not run unless you create a container of it. Both these options are kind of useless because that is not what we are looking for. We want to go for persistent data storage, where if something is getting changed, I want to persist that change forever. And if this is the kind of goal you are having, then you should go for something called as a volume, and that's where the volumes are needed, and that's where the volumes we are going to use one by one, or maybe a different type of volumes as per our need. So saving the data beyond the container's life cycle. So even if the container is going to get removed, still I want to persist the data. If I want to do it, then I have to go for persistent data storage. The data is stored outside the container. How? I'll show you that when we go to that topic, when we go to that example there. So there are three options. One, local storage. Two, static storage. Both of them are kind of useless for me. If I want to pursue the data, I should go for only the last one. This is the third one, which is something like Docker volumes, with which we can pursue the data permanently. Docker registry is nothing but where we are going to upload our images. For example, Docker Hub, that is one of the Docker registries there, public registries there. Tomorrow we'll create our own registry called as a DTR, Docker Trusted Registry. We'll see how to do that tomorrow. Okay, so now if I want to do it, there has to be something called as a storage driver, which is going to do the job there. So probably when we are in Docker, then Docker provides different storage drivers in order to deal with the local image, local storage, or deal with the image layers, or deal with the static image storage, so on and so forth. So Docker supports several different storage drivers, and depending on operating system, they will vary. So by default, when we are going to install Docker on different operating system, the Docker knows which storage driver it has to use. It will automatically select one. So there is one something called as overlay 2. It is a preferred storage driver for all currently supported Linux distributions. So when you are on Linux, generally it will go for overlay 2. It requires no extra configuration. It comes by default with the Docker. So we don't have to do anything for that. Which need you are talking about, Ashraf? We are talking about storing the data outside the container so that we can persist the data. When I say persist the data, where I want to store the data permanently, Even if the container is not going to be there, even if the container is kind of removed, or if it is stopped, still I want to persist my data. That is the reason why we should go for volumes. Okay, wait, I'll show you the demo, you will understand that. So there is something called as overlay 2. Remember that it is generally used in all supported Linux distribution. Remember this connection because you might see one of the questions on this topic as well. AUFS, preferred storage driver for Docker 18.06 and older. This is kind of gone. Gone in the sense, generally it is not used because we are using Docker 19 onwards. So if you are using Docker 19 onwards, it's already kind of gone. It is running when Ubuntu 14.0 kernel 3.13, which has no support for overlay 2. That's why I said it's gone. So it was the older option. Now it is replaced by overlay 2. Device mapper, it is supported, but it requires the direct LVM for the production environment. So I don't know whether you have heard about this LVM before. It's like logical volume manager. Those who are coming from RHCSA, they might recall this LVM. So if you have LVM, then only you can use a device mapper. Otherwise, device mapper cannot be supported. There is one more. It's something like a BTRFS or a ZFS used if there are the there are the backing file systems, the snapshot supported file systems. If you are having one, then you can go for it. Or there is a virtual file system VFS intended for testing purpose. Will not be able to use that in the production. So it's only for VFS. It's only for testing. So which one by default will be used? So by default, it is going to use this overlay 2. How do I get that? How do I get the information there? I'll show you that information. See, you can go back to your command prompt and use the command docker info. There is a space in between, docker space info. So this is the command that you are going to use in order to find all the different options available. So client is not what I'm bothered about. This is the server, which is going to tell me how many containers are running or how many containers are there, how many images are there, which server version is running, which storage driver it is using. And yes, it is telling me it is using overlay 2 storage driver. So this is where it shows me the overlay 2 storage driver. Okay. So it is by default used for maybe Mac. It's going to be used for even a Linux operating system as well. So I'm going to say Vagrant SSH D node 1. I gave you that file today. Follow those steps, get the things done. So tomorrow you can have the cluster created along with me, and then we'll do some kind of cluster magic. We'll see tomorrow. I'm going to go back here and say the Docker info on this is the Linux Ubuntu 18.04. And yes, here also I'm saying the same thing. Overlay 2 is used. So this is where we can see by default it's going to use overlay 2. So this is the one with which we can try to store the data permanently. Now, when we want to do it, there are options actually. So maybe we can say something like local storage. Local storage is nothing but the data which is stored inside the write layer. Probably this is something called as a local storage. The size taken by the container. The size is nothing but the data on the writable layer, and virtual size is nothing but the container only image data and the writable layer size. I hope you still recall if this is an image I'm using. So this is, let's say, image, and image is having, let's say, 2 layers. Then by default, both those layers will get copied. So this is how the layers will get copied. And on top of that, this is not an image anymore. This is kind of a container now. On top of it, a new layer will be added. This is the layer which we call it as writable layer. So this is image. This is a writable layer. So combining this together, I'm going to call it as a container. You see, this is the container size. This is where you can see the container size. And this is where you can see the virtual size. So whatever is the size of that image, that is a virtual size. So multiple containers share the same image. Hence, multiple containers share the same image, hence the image size will be shared. So when we are creating multiple containers on the same image, we talked about that all of those containers will share the same image file or same image layers. So you will see the same image there. Again, I can go back and see if I'm running any container. I guess I'm running Mongo right now. So I'm going to go back here and say Docker, or maybe we can create quickly one. I'm going to go back in Ubuntu right now and we'll create a very simple container. So container run minus itd. I'm going to run Alpine container very quickly, and I'm going to pass a name. I'm sorry, say underscore name. Sorry, minus name Alpine, and this is Alpine. So hopefully it is going to create that very quickly. This is an Alpine image, very small Linux. We used that last time, 5.5 MB. And if I say Docker container, I'm sorry, container ls, so I see that the container is running, and hopefully if I look at container inspect command, inspect Alpine, so that is the name I gave last time, I'll get every single information right here. So probably if I just scroll up, I'll get all the information, the state it is running, blah, 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 image it is having, and so on and so forth. So probably I'll get all of this information, and hopefully somewhere you will see the size as well. This is one size, this is SHM size, and probably that's only one size I'm going to get as a total size there. Or maybe we can just scroll down and probably we can go for all the different layers, and then we can combine the entire size there, and still I'm going to go back, I'm going to say that this is the total size of it. So the total size of container is nothing but the total size of image plus the writable layer. That's it. That's how we can get the local storage. This is something which is going to get created by default. So if the container is already created, I can say this is going to be an exec minus it. This is the Alpine image. I'm going to go back and say bash. Bash is not supported. sh is, I'm sorry, Alpine. So what the hell? Alpine. And maybe I can create a directory. So I'm creating my dir, for example. If I go to my dir and if I say touch, let's say file, starting from 1 to, let's say, 1,000 files I'm creating. If I say ls, oops, touch dot dot, and it's going to create, let's say, 1,000 files there. Are you kidding me? Okay, it's oh yeah, that's an sh, that's not bash. This is sh. That's the reason it's not supporting it. Bash should not support it. It's okay. So probably it is creating this file, and if I say exit and come back inside it again, I can see that I can go back to my directory. I can see the file created. It's there. It's kind of getting stored till the container is available. So till the container is available, the data is getting written inside that writable layer. This is what the local storage of that container is. So when we say, hey, I'm not going to need this container anymore, and if I say Docker container ls, what's the name? Alpine, I'm going to say rm minus force, sorry, minus force alpha in, you will see that it's going to get deleted. And once it gets deleted, you know that it's going to delete both of them, the writable layer and the image layer. So that's how it is going to do the job. So that's why the local storage is a bit riskier. Now let us see the persistent option. So persistent storage, this is where the volumes are used. Okay, so pay closer attention, because this is where we are going to see how the persistent images and how the volumes are going to help us to understand, or to put the data outside the container and permanently store it. Robin, what can be the maximum size of writable image? There is no such size restriction. So you can use as much size as you want, depending again on the disk. Okay, so there's no such restriction there. Okay, so let us see the persistent storage. The downside of using the local storage for containers is nothing but the data does not persist when the container is removed. I just showed you that. So if the container is removed, the writable layer is gone. And when the writable layer is gone, whatever you have added in the writable layer is also gone. And it's kind of, we are kind of lost it. Another issue is writable layer is tightly coupled to the host machine. You will not be able to share it across the machines. And that's the main problem of sharing as well. Let's say you are having containers running on multiple machines and you want to store the data at one single location. It's not possible with something like the local storage. So we want to search for better options, and the better option here is the persistent storage. That is volume, precisely. The volume provides a persistent storage. Volume is the way we are going to share the data amongst multiple containers, or we can store the data outside the outside the container. It allows to share the data amongst the container. It can be managed using a Docker CLI command. That's called as, I will see that in a second. So that's a volume command we are going to use in a minute. And volume does not increase the size of container using it because it gets created outside of the container. Don't worry, I'll show the real diagram and you will understand what do you mean by it. Say, when we talk about the persistent storage, so there are a couple of ways you can do it. One is a Docker volume. The second one is called as the bind mounts, and the third one is called as a TMPFS mount. Out of that, TMPFS mount is for temporary, or you can say it's just for testing purpose. There is no real use case where we can use it, and most of the important disadvantages is it's available only for Linux. It's not available for Mac. It's not available for something like a Windows. So you can't even test it if you're on Windows. So if the container is committed, then tempfs is not saved because this is the temporary and stored in the host's memory. It's a tempfs, means it's getting stored in the memory. When the container stops, the tempfs mount is kind of removed. It acts like a RAM. So not a kind of, the one which we are supposed to use in the production environment, but still Docker has given you an option there. So which one should I go for if I really want to go for storing the data permanently? You have got two options. Either you can go for volume or you can go for something like a bind mount. To be precise, both of them are going to do similar jobs. It just where it gets created that defines whether it is a kind of a volume or whether it's a kind of a bind mount. We'll show you an example and hopefully you will understand that. Okay. So see right here. This is volume. The volumes get stored in the Docker managed FS of the host. When I say Docker managed FS, it's like /var /lib /docker /volume. So here you will see the volume gets created. So /volume. So there the volumes will get created. Again, that will be managed automatically by the Docker. So we don't have to do anything for that. Everything will be managed automatically. Okay, so that's a directory where you can find it. It supports the use of volume drivers, the one which I mentioned earlier, overlay 2 and others. So those are supported here. Bind mounts are stored anywhere in the host. That is, you can also mount a local directory with the containers to share the contents of it. Most of the times, if you really want to store the data outside the container, you will prefer using volumes than the bind mounts. I'll show you both the examples one by one. See how simple is that. So to understand that example, I'm going to go back here and say, I'll create a MySQL container. So MySQL is the better option because when you are saying MySQL, I want to really persist the data. Okay. So let us understand first what happens, and then we'll try to use a volume and see how the volumes can be used here. I'm on Ubuntu right now. Should I? It's okay. It doesn't matter whether am I on the Linux or whether I'm on the Mac, because ultimately it's a Docker. It doesn't matter. So I'm going to go back here and say Docker image ls. Seems like MySQL image is already there. That's great. I'm going to copy I'm going to create a new container out of it. Watch this. So I'm going to say Docker as usual, container run minus itd, minus name, MySQL, minus e, if you can recall, environment. This is very important. It's going to be MySQL underscore root underscore password. I'm going to set that to something like root for my testing. So this is MySQL root password. Probably if I want to use it outside, then I can say 3306 on my machine will be mapped to 3306 on the container side. And this is going to be the MySQL. That's it. So the container got created. You see, this container is now going to store the data inside the container itself. So this is the command I'm using, guys. Do it along with me so you will understand what is going on. Okay, so here I am. The container must have got created now. So if I go back and say Docker container ls, see the container is created. I'm going to say exec minus it MySQL bash. So if I say bash MySQL minus u root minus p root and say create database. Let's say MyDB, for example. I'm going to do one thing. I'll just write this right here. It will be easy for me to copy and paste it a couple of times, So this is SQL. So again, it's going to be like create database MyDB. You can copy it from here, guys. It's already there in student portal. So 306, 3306 or 306? No, it's 33. It's okay. It doesn't matter actually. It's completely fine. Anyways, we are not going to use it anyway. So Praveen, I know I made a mistake, but it's okay. It doesn't matter. For now, it doesn't matter. It matters when we are having other applications which are reading the database from here. Okay. So use MyDB. I'm going to create a quick table here. Let's say create table person, which is going to have an ID, integer, primary key, auto underscore increment. Okay. Name could be varchar, let's say 100, and address could be varchar 100. That's more than sufficient for testing. I'm going to create a couple of rows. So insert into person, want to insert, let's say, name and address, which is going to be values, say person 1, and address is equals to Pune. Oops. Let's add a couple of them. That's person 2, person 3. Let's say this is going to be nearby Mumbai, and nearby, let's say, Satara. Okay, so let's copy this. I think the database got created earlier. So copy this and go back to the terminal, and hopefully we have got select star from person. Hopefully it's going to show me all the data there. Very nice. So now we have the data here. Okay, now see the problem. I'm done with it. I'm going to go back and see what has just happened. So what happens here is, before coming down to the diagram side of it, I'm going to search for MySQL here, and we'll show you something very important. So when we are having the MySQL image here, you see inside this MySQL, it is going to store the data, data to slash var slash lib. Exactly. It's going to store the data somewhere here, slash var slash lib slash MySQL. So what happens here is this. Watch this. This is the container we just have created. This is the container. Inside this container, this is the database. So see where I'm showing you the database. The database is created here, where inside this directory slash var slash lib slash MySQL. So this is where we are storing the data. Because of course the data means there will be tables here like what I just created here, maybe something like a person table we have created, or depends on you how many tables you want to create there, and so on and so forth. So all the tables, all the data you are going to create here will be stored right inside this particular location. So this is the location which is inside the application, inside that container. So this is the current scenario. So this is what we have done right now, because we haven't used any kind of volume. The data got created right inside the container. So this is the data. Okay, that's a database, but this is where the data is getting stored. Where is it? It's in slash var slash lib slash MySQL. Great. Now what? See the problem. Now if I go back, I'm sorry. Now if I go back and try to delete the container, docker container, again, ls, oops, not here inside. I mean inside the MySQL container. Sorry, my bad. Here I am, docker container ls. This is the container. I'm going to delete that. rm minus minus force MySQL. What the hell? Container MySQL force. That's it. So container got deleted. So if I create a new container now, hopefully you can understand. If I go inside the container and if I say select, sorry, MySQL minus u root minus p root, root, the hell, root. Okay, it's still building it, I guess. Just wait for a minute or two. Still building it. Just wait, because sometimes it takes time. So just wait for a couple of seconds and then try again. So MySQL minus u root minus p root, got it. And if I say show databases, you see what has just happened. You lost the database. You lost the database because I have deleted that container. When I say I deleted the container, the data is also gone. The data is also gone. So how do I pursue the data then? To pursue the data, I'm just going to call this as MySQL. I'm going to use the same MySQL again, but this is without volume. This is so risky that whatever I just did there, the database, the table, and all of that, it's gone. It's gone because we created that without the volume. Now, I'm going to go back here and create a container, see what happens here, and see the difference now. This is where I'm going to call it like with volume. So let us understand what is that with volume and how we can create that volume and how we can attach that volume here. See, this is the container, by the way. This is the container. This is the container. And both of them are going to be, the MySQL containers. So see what's going to happen now. To do this, I'm going to go back here and first, okay, let's delete that container. The container is of no use right now. So let's delete that container and let's see what needs to be done here. Before I do anything, I want to simply first see how many volumes are there by using a command docker volume ls. So when I say docker volume ls, it shows there are no other containers, I'm sorry, other volumes than these two. These two are used by some other containers. That's the reason why Docker must have created those volumes there. I can use the volume prune command and see if it is deleting it. Right now, those containers are also deleted. So the volumes we could see last time, they're also got deleted. So there is no volume here. I want to create a volume here. I'm going to say Docker volume create, and I can say maybe let's say my volume, whatever you can say there. So my volume volume got created. You see, I'm going to put all of these commands right here, so it will be easy for you to understand what we are doing here. So docker volume ls will give you list of volumes created on your machine. Docker volume create whatever my volume will give you a new volume here. So what has just happened? Look at the big picture here. This is my container, but you know what? The container is running inside your machine. Sorry, I'll do it here. So this is the actual machine. This is my machine. This is my physical machine. So in this physical machine, we are running two containers there. So this is my machine. What has just happened here is just, right outside the containers, somewhere here, I have created a volume. Think about a volume as a kind of a directory, and this is really a directory. So this is where we have created a volume. So this is like a volume we have just created inside a directory /var /lib /docker /volume. Under this you will see a new volume. That's what we have created as my volume. See, the my volume is now outside the container. This is my container 1, this is my container 2. So first, second, and this is created outside of both the containers. Now what I'm going to say here is, when I create this container, I'm going to say that, hey, I know that MySQL stores data inside /lib /var /mysql. So I'm going to kind of fool that fool that container, saying, hey, I want you to store that in your location, but I'm going to create a symlink or symbolic link to my external volume by saying something like this. Check this out. I'm going to create this container by using similar command, adding one more part or one more flag here, something called as a -v for volume. I have a volume named my volume. This is the volume I have created here. This is my volume. And I'm going to map it to the containers /var/lib/mysql. I'll show you what happens here, but wait and watch. I'm going to create this one. I'll put this command right here inside the list. So you can copy and paste and see whether it is giving you the similar result. It's better we can just put it right here. So this is where you are going to copy this command and create a container with volume. This is V for volume. This is the volume that we have created here. And right after creating the volume, only you can run this command. Now see what happens. Behind the scene, you see that this is where the database is going to get created. So this is not going to change. This is still going to be the same location, /var/lib/mysql. But you know what? Because we have kind of created a volume, this MySQL directory, the one which is inside the container, is mapped to this particular folder here. So it's a kind of a symbolic link, or it's kind of a shortcut. So you can call it as a link. Link is nothing but, you can say it's kind of a shortcut. So basically, whatever you can do with shortcut is exactly what it is doing by using this volume command here. So it's kind of creating a shortcut to this one. So tomorrow, if I create a new database here, the actual database will be created on disk, not inside the container. The actual database will get created outside of it, because this is kind of mapping to this particular container or this particular directory here. So the database will be created right inside this directory instead of creating inside the container. Yeah, it's a kind of a symlink, or it's kind of a soft link or symbolic link. It's pointing directory, it's a shortcut, whatever you are going to call it as. So if I say, hey, I created that container, now the container must be running. So if I go back and say container, are you running there? Oh yeah, it is running. So I'm going to go back to that MySQL container. I'm going to copy these 4 or 5 commands, whatever they are. I'm just going to copy this and oops, we'll have to say MySQL -u root -p. Root is the command. What the hell is that? MySQL -root. Yep, that's it. And probably I'm going to put this command and see I've got the data. So I've created the table. Where the table is created, is that table created inside the container or outside the container? You can say that because MySQL is going to create the container, create the table or create the database in this location, my /var/lib/mysql. So container thinks like it is creating it inside the container, but actually the data or the table or the database is getting created outside of the container because we have attached a volume, and this volume is a kind of a symbolic link to the directory which we have created there, which means if I exit this, and if I delete my container, watch this. I'm going to say remove that container. So I deleted that container. So even if I'm deleting this container here, probably you can understand this now, that even if I delete that container, still my database exists. I hope so. Let's give it a try and let's see. So I'm going to go back here, make sure that you are using that -v my volume there, because if you don't do it, it's not going to work. So now I've created this table, I've created this container. Now this is the real test. I'm going to go back, go inside this container and say MySQL, -u root -p root. And if I say show databases, sure enough, you will see MyDB. Look at that. Sure enough, you will be able to use MyDB, and sure enough, you will be able to see select star from person, and you still see I've created a new container. I got the new ID, but I still could persist my data even if the container got exited, container got deleted, container got removed. Still, I could persist my data. This is what we are going to need in the production environment, because if I know that the container has to run MySQL, then it's very much riskier to run the container without using something like a volume. If you do it, Removing container will lose the data, but when we are going to do it in this way, that of course, when we are creating a container, if you are attaching with the volume, this is going to persist the data, because the data is not going to get added inside the container. The data is going to get added outside the container, which is called as a volume. So volume is going to get managed by Docker. I'll show you where the Docker is going to create that volume. So go back to /var/lib/docker. I'll have to say sudo -i. And then if I say /var/lib/docker, because it requires super permission. So if I say there is kind of a volumes, so /var/lib/docker/volumes, there is a folder called as my volume, you see, and under this you will see the data, and under this data, this is all your MySQL's data, you know. So this is where the MySQL must have selected. You see mysql.idb, which means it's a MySQL data, you know. Again, if I go back to my DB, I'm sorry, cd my DB, that's my database here. And you see that this is the person.idb. This is where the data has got stored. So data has got stored right inside this directory, /var/lib/docker/volume/my volume. So this is where the data is stored. And because it is stored outside the container, you see, even if the container is kind of deleted, my data is persisted. My data is still there. And that's what you call it as a persistent data, persistent or persisting the data. I hope you must have got the concept here. It's very simple concept, but very important concept from the production point of view. You do not want to lose the data. Imagine your database is running inside the container. Your customers are giving so many information that you want to persist. And if you do it like this, your container is gone, your data is gone. So you can't take that risk. And if you do not take that risk, this is the way you can do it. With volume, you can do it. It will create outside the container. And yep, this is how we can do it. Good thing here is, if I want to, create one more MySQL container, and I'll show you the example here. Okay, so I'm going to go back somewhere here. So it'll be using the whole command prompt. And if I create one more container out of it, I'm sorry, I can't use the same name again. You know that you cannot run multiple containers with the same name. So I'm going to create one more container with MySQL 2. And what the hell? Port is, oh, I'm sorry. I can't use the same port. Sorry, my bad, my bad. I don't need any port actually, to be very precise, because I'm not having any other application to do it. So I'm going to create this, one sec. Let me see. Docker container ls -a. That's MySQL2 got created. I'm going to delete that. So Docker container rm MySQL2. You see, that's where we are deleting it. And I'm going to create it again, MySQL2, without port mapping. I'm going to create one more MySQL container, and I'm going to create one more MySQL container. That's going to be MySQL2, MySQL3, and MySQL4. So I've got 4 containers now, and all of them are having the same volume here, which means even if I go to any of the containers here, so I'm going to say exec, I'm going in MySQL right now. We already have gone there last time, it doesn't matter. I'm going to go back into MySQL2. I'm going to do the same thing. So it's going to be MySQL -u root -p. Root is the password. What the hell? Root is the password. It's still getting created, I guess. Just wait for a second. Sometimes it takes a couple of minutes in order to take it back into the memory. So just wait, hold your patience. MySQL -u root -p root. It seems like the other container is using it. That's the reason why it's not allowing me. But you know what, because they are kind of stored, or they are kind of using it here, everything is kind of shared across all of them. So probably I don't need to go for the MySQL database itself. I can go back to that directory /var/lib/mysql, and even if I create a directory here, or why MySQL, then maybe I can delete that data. I can delete the MySQL containers, and I can create a very simple Alpine example. Check this out. By the way, someone was asking like how to create the contain, how to delete all the containers here. So see, sq, you can say docker container ls minus q, and it will show you the container IDs there. I think I need all the IDs there. So minus a minus q, I see all the IDs here. So I'm going to say the command, just put this command inside a parenthesis and say dollar. This is the shell script. So when I say dollar this, it's going to, right now it's not going to work, but if I just say echo, it's going to give me the list of all the IDs there. So instead of saying echo, you can say docker container sorry, rm, and say minus minus force. And if I do it, you see it is going to delete all the containers at once. So you see all the containers are gone. So probably I was saying that earlier, that that's a better option, and this is the better option. You can do it right here, and this can be used for images as well. So both of them will do the same job, deleting all of them right there. So instead of using MySQL, I'm going to create Alpine Linux. It's going to be very simple. So I'm going to go back here and say docker container, let's say run minus itd. It's going to be minus minus name. I'm going to call it as a first. That's my first instance. And going to be an Alpine here. Will it be, I'm sorry, will it be run minus minus name first, Alpine docker container. Sorry, it's my bad. That's it, sufficient. I'm going to go back here and call it as a second, and I'm going to call it as third. So I've got 3 instances here. And oh, sorry, my bad guys, forgot to attach volume. I'm so stupid. I'm going to create a new volume here, docker volume create, let's say my volume 2. I have to, of course, attach a volume there, right? So I want to create that first, second, third. But before that, I want to attach a volume. Let's say my volume 2. Watch this. My volume 2 colon, let's say slash src. So on slash src, I'm going to attach it. That's my first one. Okay. That's my second one. And that's what the third one I was looking for. So that's it. So now I have 3 containers. Those 3 containers are sharing the same volume. See the magic? I'm going to go back here and say docker container exec. The first one, I'm going to go back to the bash. Oops, this is kind of a Alpine, so we can use sh. Sorry, exec minus id. And I got the command prompt here. So I'm going to go back in src, right? I'm going to create a new directory. I'm going to say this is the first one, and write mkdir first. I'm inside the first. I'm creating a directory called as first, and I'm going to say touch. Let's say this is going to be file 1 and file 2. So I've created 2 files here. I'm sorry. Maybe I'm going to say ls, and see that I've created 1 directory and 2 files, file 1 and file 2. Now I'm going to go back outside the container. I'm going to go back to my operating system and coming to the second container. Watch what I'm doing. I'm in the second container. I'm going to go back to the same directory slash src. If I say ls, I'm in a second container, and still I'm able to see what my first container has done. I'm still going to create a new directory like second, what I've done earlier. And like this, I'm going to say touch file 3 and file 4. So I'm creating a directory and I'm creating 2 files, 2 more files. That's it. And I can do the same thing right here and say third. And if I go back to slash src, you see, I can still see for a second. I'm going to create the new directory third and touch. I'm going to say file 5, file 6, ls. So I don't know whether you can see this, but even though I'm going to go back to the first and say slash src, and if I say ls, you see all the files and directories, which means whatever those 3 containers are using one common volume, they are able to share the files in real time because they are using actually the same directory. That's something which is created outside of the containers. That's how we can share the contents among multiple containers. I hope you can see an example here and you can understand how the data can be shared here. Okay, that's what I said. You can use the volumes for creating shared, or maybe you can use it for sharing some contents amongst those containers. Yes, Samrat, is there any limitations on the size? There is no limitation. It all depends on your disk, the physical disk. If your physical disk is having limitations, you can't help, but there is no limitations from the Docker side. Okay. Until if something or the job is processing and the container got crashed, is there anything that so we can recover the container as well as the job? Without Docker Swarm, you can't. So tomorrow you will see what is an option there. Okay. So Anshul, yes, there is an option, but not without Docker Swarm. So tomorrow you will see. And of course, the Kubernetes, of course, there is orchestration, what we are looking for. So the whole reason behind behind that going for that Kubernetes is the same reason. Like if the container is crashed, how can you survive? How can you start that container again? Who will do it for you? That's Kubernetes or Docker Swarm. So tomorrow you will see Docker Swarm. Next 2 weekends, you will see something like a Kubernetes. Okay. Tushar, can we see a creation dynamically if we sh into different containers and different terminals? I think you already have seen that right now, right? Yes, Mayur, microservices communicated in that way only. Absolutely, microservices are where they are going to communicate with each other. So that's the simplest way we can share the contents amongst them. Yes, Praveen, can we attach multiple volumes for multiple Docker directories in one single Docker? Yeah, of course, one single container, you mean to say. Yes, you can. It doesn't matter. You can attach as many volumes as you want. So there is no limitation. The good thing here is, let's say, I'm going to delete all the containers like what I did last time. I'm going to delete all of them. And let's create only one container right now. When I say I'm going to create one container, I can attach one more volume here. So I'm going to say -v. I'm going to call it as my volume 3, and then I can say, let's say /app, for example. So my volume 3 does not exist. I know I didn't create that yet, but this is the beauty of it. If I go back and say docker volume ls, it will create a volume if it does not exist. So if I say volume 3, I know that this is not what I was having earlier, but if it is not there, Docker will create that volume for you. You see, that's my volume is now there. So that's how you can do it. Okay, so probably you must have got the point now. This is how we can do it, you know. So what the hell is that? Okay, so Docker container, I think I'm not going to need them. So let us delete that. It's of no use. That's it. Okay. And I think Docker volumes, I'm not going to need them as well. So I'm going to delete them. So how do I delete them? I can either delete them one by one, or I can call prune command. Prune command is the one with which you are going to say those unused volumes, delete them. You see, total reclaimed space is almost like 193 MB. Docker volume prune. And when I say volume ls, all the all the volumes are gone. Okay. Atul, what is the size of multiple volumes in one container? What is the use of multiple volumes in one container? Of course, it depends actually. If you want to, if you want to share multiple directories, what if there is one shared directory amongst two containers and another directory with other two containers? So it is possible, isn't it? So think about the scenarios, like one will be used for MySQL, one will be used for sharing some other files. As simple as that, you know. So probably the requirement will be yours, but this is how we can do it. Okay. Okay, so now you know like how to use those volume options for you. This remove all command won't work in Windows. No, it won't work in Windows, Prabal. This is for Linux. This is for Linux in a sense. This is a shell script, and that is the reason why I'm insisting all of you to use Linux. I mean, stop using Windows, because when you are going for production environment, no one will use Windows there. You know, so most of the times you will use Linux. So be ready for the production environment. Yeah. Will it create in a multiple? Will it create replica in multiple volumes? No, it won't create any replica. The directory will be created only once, and if it is there, it won't recreate it. Okay. Mayur, can we say in simple words, volumes are like the folders created per system? Yeah, of course. That's what I said, right? I said that this is nothing but a directory which is created outside of your container. So this is the exact path I gave you, slash var slash lib slash docker slash volume. So that is nothing but a directory where the data will be persisted. Okay. Who's that? Robin, can you please copy the commands to enter username in MySQL? Okay, no big deal. It's a very simple command, by the way, but still I'm going to put that right here. It's MySQL. I mean, go inside it first. Docker container exec first bash, whatever, minus it, and then you can say, I'm sorry, MySQL minus u root minus p. That's where we are going to put the password as a root. Depends actually. It's a root what we have decided earlier. Okay. Akshay, is there any default size for volume? There is no default size. It grows as you put the data. It's just a directory, right? So it grows as you put the different files there. So there is no different default size for it. Prabal, it seems similar like AWS EC2 local and EBS persistent in terms of Docker. Absolutely right. Yes, Prabal, it's exactly the same relation what you're talking about, EC2 versus EBS. So like you can attach EBS externally, you can attach volume externally. Absolutely right. It's like the pen drive, So you are attaching the pen drive, copying the files there. That's it. So even if you shut your machine down, you still can have all the files inside that pen drive. You can attach it to other machine and you can get it there. That's how we can do it. Okay, that's right. Okay, so now we know what is something like a persistence option available here. I think the next point is something like Docker network. Should we continue with the Docker network today or should we start a little bit earlier tomorrow? What do you think? Almost 70% people are already gone. Exactly. What's the point of doing it now? No problem. Let's do it tomorrow then. Guys, please remember we are going to start at 7 o'clock tomorrow. Okay. So we'll finish the Docker network. Then we'll have to finish the YAML. YAML is something that is used for Docker Compose. Was it heavy, Prabal? It wasn't. It just because of the multi-stage, I guess. Yeah, I know. That's a little bit heavier topic. So probably Docker network is, oh my God, this is something which is my favorite topic, networking. That's the reason why I'm not going to talk about this right now. I want everyone to pay attention to that. By the way, I've shared one link with you earlier today on your WhatsApp group for that YAML. So I would really request you to go through that video at least once or twice. So you will directly understand that YAML. So I don't have to waste too much of time here. And at least if you can write the YAML on your own before you come for the session, the Docker Compose is going to be very simple for you to understand. Okay. So this is something that, yes, you will have to you'll have to do it tomorrow. So we are going to first finish something like a Docker network. Second one we are going to finish would be something like a YAML. YAML is hardly 5 minutes. Docker Compose won't take more than let's say 10-15 minutes, not more than that. And then we will start with two more topics. One is the Docker Swarm, very important. Orchestration is what we are going to see there. And finally, we'll see Docker EE for Enterprise Edition. Okay, so we'll do it there. Great. So this is kind of agenda for tomorrow. So tomorrow we are going to finish all of these topics. Okay, no problem. Yes, Adul. If the replica data is not stored in the multiple volumes, then how to store the data in the specific column, specific volume? The directory, didn't you see that? In our, where is it? Where is it? Where is it? In our command, did you see last time the command I used for, see here? So my volume 2 in /src and my volume 3 in /app. So whenever you want to store the data in my volume 2, you will store the data inside src. And if you want to store the data in my volume 2, my volume 3, you will have to store the data inside app. You see, Atul, this is how we can do it. Okay. Yes, Atharva, I'm going to share that with you as well. Don't worry. Chamak, yes, yes. Yes, exactly. Akash, you are using it for YAML. That's good. That's good. So please take a look at that video, so at least you will get an idea what exactly it is. Okay. Please share with the DAX students as well. Yes, I will. Shubham, yes, please share it. Yes, I will. Don't worry. Who's that? Robin? Cannot connect to MySQL using socket through the socket. Blah, 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 blah. It's just because of the MySQL. MySQL is not configured to share the data or to let the multiple connections to connect to the same database at the same time. So it's not the container, it's the MySQL's problem. That's the reason I took another example of Alpine. Okay, it's MySQL. I don't want to waste your and my time to configure the MySQL there. It's not of any use, in fact. It just, I wanted to show you the demo, like how you can share the contents with multiple containers. That's it. Oh, can you explain by example? Of course, not a big deal. See here, I'm going to go back and use the same container which I created earlier. You see my volume and my volume 2 and my volume 3. So let's go back and say docker container exec minus it. What is the name? First, for example, and I'm sorry, it's Alpine, right? SH. So if I want to store data in my volume 2, maybe before I do it, I'm going to go back to slash var slash, I'll have to say sudo minus I, watch Atul, cd slash var slash lib slash docker slash volume, sorry, slash volume slash my volume 2, I'm sorry, volume slash my volume 2. You will see under underscore data there is nothing, I'm sorry, it's empty. So this is empty. Okay. And if I go back to my volume 3 underscore data, both of them are empty. Okay. Now watch this. I'm going to go back inside the container and we'll try to see something there. So where is the exec? Here it is. Now I know that my volume 2 is attached to slash src. So if I go to slash src and if I create a directory, maybe I'll say this is this is volume 2, right? So I'm going to say this is volume 2 underscore directory. And if I go to that volume 2 underscore directory and let's say touch test file 2, that's it. I'm going to go back to another directory slash app, because you see this is where we are kind of attaching it to app, and there I'm going to create a new directory, volume 3 underscore directory, and let's go to that volume 3 uh, and then we can create a file, let's say touch file whatever test file 3. Okay, so I'm going to go back to the directory again. I'm sorry, sudo minus I. I'm going to go back to slash var, I'm sorry, slash var slash lib slash docker slash volume slash my volume 2 slash data. And if you see here, this is volume 2 directory, and dot slash my volume 3 underscore data. If you say ls here, you will see the volume 3. So now this is how we are kind of specifically adding those two directories to those two volumes. So this is how we can do it. Yes, thanks for confirmation, Atul. So this is how we can do it. Okay, that's great. So this is how we are supposed to do it, and this is how we have kind of done that job. That's great. So probably I think we are done with that, and kind of volume is something that you must have understood now. Okay, so tomorrow we are going to look at the very important topic that's called as networking. Another important topic, Docker Swarm, important topic I'm saying. And the last one is something like Docker EE. So today I'm going to send you, later today or maybe later tomorrow morning, I'll send you one link for registering yourself for Docker EE. It will give you 1 month, as I said earlier, 1 month trial period. So you can use that 1 month and probably test the things out there. Okay, so see how it can be done. Okay, so I think better we can call it a day now, and we'll start tomorrow exactly at 7 o'clock. I'll put that message on your WhatsApp group as well, so you will not forget that. And I'll put all of these things in your GitLab registry, so you can GitLab repository, so you can get the contents and you can get the code there inside your GitLab repository. Okay. So as usual, thank you very much, guys, for attending today's session. I think really you must have understood those concepts. If you have understood them, practice them before tomorrow's session. Tomorrow's session is little bit heavier than today's. So see if you want to join first. If you want to join it, then I think it's better you can just keep couple of cups of teas or couple of cups of coffees with you, so that you can sip one whenever you think it's a little bit heavier dose. Okay. Anyways, I'll see you tomorrow exactly at 7 o'clock. Till then, bye bye. Have a very good night. Tomorrow, before you come for the session, please go through those container full of TS. Please look at those links which I'm going to share on your WhatsApp group. Okay. I'll see you tomorrow. See you. Bye bye.